Right, so now we have finished the theory part of digital circuit design. Now we are into the applications. Applications in computing, not in general digital electronic, applications specific to computing. Uh, okay, right. So we can subdivide the usages, so usage components, into two categories. That is combinational components and sequential components. So basically, a component, circuit component is a circuit that does a well-defined task. Right? That does a well-defined task is called a component. So you know what is a component is, right? For example, if you take a vehicle, engine is a component, gearbox is a component, starter motor is a component. If you take a computer, processor is your main component. So then you have RAM component, SSD, okay, monitor. Likewise, digital circuit component is a digital circuit that does a well-defined task. So that task can be some processing, doing some processing, or that task can be doing some controlling, or that task can be retain the value or memory. So there are three type of usages: processing, controlling, memory. Right? Processing, controlling, and memory. So one component is not going to do all when it comes to tiny components, but one of these. Okay, and that is the usage wise. But when it comes to the behavior wise, how the component behaves, we can subdivide it into two types. Now these are serious topics. Okay, so digital electronic is the hardest topic in engineering, right? So we are now into that those concepts, super serious. Okay. So you can understand this if you are very serious, if you have that kind of a capacity. Otherwise, you will not understand it. Maybe you will feel like understood, but actually you don't understand. So therefore, be cautious, be serious. Right. So according to the way these components behave, we can subdivide them into combinational components, sequential components. Right. So every digital circuit component is either combinational component or sequential. If it is a small component, so of course, if it is a big component, maybe it has both sequential and combinational parts. But we look at the atomic components, small components that does one well-defined task. At any time, if you have any questions, you need to ask because this is not straightforward to understand. Right. So what is mean by combinational circuit component? So a digital circuit component is said to be combinational component if its output depends on only input. Right. So the output depends on input. Of course, assuming that your component is working. Component is working. Right. So so that means your output doesn't depends on the current situation or current memory. Okay. So you will not proper understand this when until we go to the second type also. Just for the time we remember, if there's a component, its output only depends on input. It's a combinational component, combinational circuit component. So that means its output doesn't depend on the current memory. Okay. So the second type is called sequential component, right? Sequential component. So in sequential component, I will show you sequential component block diagram also before moving to the combinational components. Your output Now this is combinational. Output depends on input only. If your output depends on both input and the previous output, right? So that means your output is also input. This is called sequential component, circuit, right? So therefore, your current output not only depends on the current input, but the previous output also. Okay. So these are harder to understand. Sequential component, very difficult to understand unless you are very serious. But what we are looking at right now is combinational components. Combinational components are easy to understand, relatively easy to understand compared to sequential. So today we will concentrate on combinational components only. So that you have enough time to think about the combination of components and prepare for ready for the understanding sequential components. Right. Under combination of components, we are going to look at four usages or four components. Out of that, this is processing component. These three are more control components. Adder, which is a processing component. Decoder, encoder, and multiplexer, all three are control components. That component is used to control. Okay. So let's take one by one. And again, if you have any questions, you need to ask. Okay. So if you don't understand and if you haven't get it clarified, that is your problem. That is not my problem, right? So it's my problem if I don't explain when you request clarification. That is then my problem. Or if I don't give that kind of opportunity for you to get the clarification. So that is my problem. I try to hide my problems. I don't have any problem in this subject or any subject I teach. Right. So let's start with adder. Let's start with adder. Adder is a combinational component we use for processing. All right. So what is the processing? Basically add binary numbers. Adder is a logic component, combinational logic component that we can use to add binary numbers. So you know what is adding binary numbers like this. Say this is also 1. Say 0 plus 0 is 0. 1 plus 1 is 2. 2 means 0 giving 1. 1 plus 0 plus 1 is 2. 2 means we don't keep anything. We give it to the next level. 1 plus 1 is 2. 0 giving 1. So can we design a circuit rather than we do it? The circuit do it. Actually, that is computer is capable of adding binary numbers. So if you have that component only capable of adding binary numbers, nothing else. So then that component is adder. So then we can find out some other components and create a bigger component like arithmetic and logic unit. That is how of computer is designed, component based architecture. Okay. So what is an adder? A digital component which is capable of adding binary numbers. Any question? Right. How do you implement it to what kind of a circuit is going to do that? Right. We are going to look at three such circuits, or three such components, which is capable of adding binary numbers. Okay. Half adder, full adder, ripple carry adder. So these are bit of improvements. So this full adder is a better option than half adder. Ripple carry adder is a better option than full adder. So when I say better, it doesn't mean that these are having some issues, errors. No. Remember, formal science is perfect. Digital electronic is always perfect. But so then how, if it is perfect, why do we say that this is better than this and this is better than this? So basically this does the half of the work perfectly. So therefore it's obviously half adder. So full adder can do the full work. So this one also half of that is done perfectly. Therefore you can't say this is false, no. But this does the full work. So then when we have something that can do the full work, why do we need another one? That is for better performance, or better way of doing that. Better way means faster, not accurate, faster. Triple carry adder. So let's take one by one. So then someone will ask, why don't we just learn this? So basically, we don't learn about these things. Actually, in reality, we use triple carry adders. But when we go like this, it's easier to understand this final version, like how it evolved, so that you will ultimately understand this better when we go with the historical evolution. Right, half adder. Half adder is a combinational circuit component which has two inputs and two outputs. Two inputs, two outputs. Say inputs are A, B, outputs are S and C, sum and carry. For example, your two inputs are 1 and 0, sum is 1, carry is 0. If this is 0, 0, both are zeros. Say 0, 1, sum is 1, carry is 0. If both 1, now sum is 0, carry is 1. This is my requirement. Two inputs, two outputs. Okay. For example, when you add these two numbers, say 1 plus 1. So this is 1, this is 1. So the sum is 0 and carry is 1. Because 1 plus 1 is 2, 2 you can't keep. You are giving to the next level. Next level means carry. Sum is 0. So this is sum, this is carry. So then my sum is 0, carry is 1. Now we have 1 plus 0 plus 1, 2. 2 means sum is 0, carry is 1. So therefore, this is the truth table. When both are 1 only, carry is 1 and sum 1. Sorry. When both are 0, sum is 0, carry is 0, obvious. Right. So then 0 and 1, sum is 1, carry is 0. 1 and 0, sum is 1, carry is 0. When both A and B are 1, now sum is 0, carry is 1. Is it clear? So that is how you add numbers. So just concentrate on one row, sorry, one column. The possibilities are 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. 0 carry 0, 1 carry 0, 1 carry 0, 0 carry 1. So those are the four possibilities for this half adder. Okay. So then why do we call it half adder? Because in practicality, when you have something like this, 1 plus 1 is, sum is 0, carry is 1. Now in the next column, you have three inputs. But we have two inputs. So that is a bit of issue. Because yes, initially you need two inputs, but then there's a possibility of a third input, carry from the previous step. but we have only two inputs. So that is why this is not the perfect solution. Perfect in the sense it works, but half of the work. Half of the work. Because when you get into this kind of a situation, where you have the two values and carry from the previous step, there's no third input. There's no third input. So that is why we say this is a half adder. So then someone will ask, is this useless? No, this is not useless because when you have this kind of a situation, first you add your two numbers and that result, to that result you add the carry from the previous step. So that means in that kind of a situation, you need to use the half adder twice. So then only you get the full functionality. So that is another reason why we call it half adder because it does half of the work. Or you need to use it twice. You need to use it twice. So then you get the final answer for that column. So every word has a meaning, right? These are not just we call half adder, right? So it has a definite meaning. That is why we call it half adder. We need to use it twice. Or only half of the job is done. So are you okay with the truth table? Sum and carry, two input, two output. So then you need to think about how to implement this. What kind of a circuit will give you this kind of truth table? That is when both are zero, sum is zero, carry is zero, zero, one, sum is one, carry is zero, both one, sum is zero, carry is one. Again, you can use sum of product or product of sum approach and do this. For example, if you interested of sum of product, you only, but you have now two circuits combined together. Right? If you look at this, you can see that this is A B bar, sorry, A bar B plus A B bar. But if you need the carry, it is simply A B. So this is A bar B plus AB bar. And this one is simply and A plus B. Okay. But you can clearly see that this truth table is pretty much XO. Remember A bar B plus AB bar is XO. A XO B. So therefore, rather than you write like this is more compact form. You can see this XO truth output. So yes, usually we go for the simplest SOP and POS, but when it comes to adders, we use XOR gates simply because it's more compact. It's more compact than going for two AND gates, two NOT gates, and OR gate. Just one XOR gate will do it. Okay. Right. So now we want to look at the circuit. So this circuit does the work. And again, we have used XOR because this is naturally XOR. We can develop this using sum of product approach, but this is going to be simple. So you can clearly see that sum is XOR when they are different one, when they are the same zero. So therefore we can have a XOR gate and get the sum. And this is clearly and when both are one only one. Okay, when both are one only one. For example, if you send 1 1, 1.1 is 1, 1 is 0. So you know the output, you know the carry, sum and carry. Okay, that is called half adder. Any questions? Any questions about half adder? Circuit, idea, purpose, drawbacks. Right. So the disadvantage of this half adder is, as I told you, when we have something like this, 1 plus 1 is 2. 2 means 0 giving 1. Now you have 3 inputs. And we need to add 1 plus 0 is 1. Then 1 plus 0 is 1. Nothing. So in this kind of a situation, you need 3 inputs, but you have only 2 inputs. Having 2 output is okay, carry and sum, but just 2 input is there. So that is where you need to use this twice, or you can't use it for this kind of scenarios. You can use it twice, maybe you add these two, and to that sum you add these two again. Okay. Right. So therefore, this is half adder, not a full adder, because you need to use it twice when we have carry from previous step. So how would you use the twice? Okay, I'll show you. Okay, this is something like this. Say 1 0 1 1 1 0. Okay, let's say 1 0 something else so that we have carry. Right. So let's say 1 0 1 0. Now first time we are working on this. So your input is both 1 1. So let's say this is AI, BI. AI is A0 is 1, B0 is 1. Now 1.1 is 0. Sorry, 1.1 is 1. This is 1. 1 and 1 XO is 0. Now remember 1 plus 1 is 2. 2 means 0 giving 1. You can see this is sum. This is carry. This is carry. You can see sum is 0, carry is 1. Yes, sum is 0, carry is 1. Now we are done. We are done for this column. Now we are into the next column. Now let's first add these two. 1 and 0. Okay. So 1 and 0. 1 and 0 is 0. And gate 1 0 XO is 1. But that is, we have only added these two. Okay. Now for that, to that you need to add this one carry from previous step. Okay. Now you can consider one of these as A, maybe sum as A, and carry from the previous step as B. Then the sum is 0. Sorry, not the sum, you take the carry. Okay. So the carry is 0. So this is A or say carry. This is B or sum. Okay, B or sum, because it's a two-step process. First we add these two, then you add these two. Okay. Now our sum is 1. Our sum is 1. Sorry. Yeah, when we add this, sum is 1. Okay. So we first add which one? So we started with red, right? Then we came to the blue. Yes. So sorry, our sum is 0. Sorry, our sum is 1. The sum is 1, and the previous carry is also 1. So therefore now 1 and 1 is 1. 1 XO 1 is 0. So therefore final answer is my final sum is 0, and there's a final carry. But we did it using twice. First we had this and this, then that answer and this. So we had to use this twice. Now next time also, first we need to use add these two, and that answer you need to add with this. That is why we say half adder. You need to, when we are in this kind of a column, most of the time you are in this kind of a column where your carry is 1. So then you need to do on twice. First do this, and that result you add with this. That is why we say you need to do it twice. Because we have two input, but we have three input in most of the cases. Third input is carried from previous. So you need to do it twice. So that is why we say half adder. Okay. So maybe you can go to the YouTube if you are not very sure yet. Ask something like half adder simulation or something. Use of half adder for adding, say simulation or whatever. I don't know whether there can be examples. So there are simulations also. So maybe one of these will explain it further. Okay. Right. So that is called half adder. Half adder. Why we call it half adder? Because you need to use twice when we have carry from previous step. So now we move on to full adder. Full adder. So full adder has three inputs. Why? Because when you are in this kind of a situation, there's a possibility that there's a carry from previous step. So then you need three inputs. Here, two inputs is enough because always this is zero, right? But from this point onward, there's a possibility of three inputs. So if you include three inputs to your adder, that is A, I, B, I, and carry I. So three inputs and two output. So this is your sum, this is your carry. Okay. Three inputs, two outputs. So then we can think of, can we develop this particular adder? And we call it full adder because now we have three inputs. One column can be added using single operation. Full operation is there. Okay. Is it clear? Full adder. Again, we need to execute this column wise. First this column, then this column, this column, this column. And when we add this column, this is your carry out, which is your carry in for the next step. Carry out for the current step is the carry in for the next step. But each step has its own A and B values. Own A and B values. Okay. That is called full ladder. But how to implement it? What is the circuit? So first of all, you need to have the truth table, right? Truth table. So now we have three inputs, right? Because A, I, B, I, carry I. Or carry I minus one previous step. So therefore, there are 8-bit patterns, and these are the possible outcomes. When all are zero, sum is zero, carry is out. When one of the value is one, now still sum is one, but no carry. Sum is one, no carry. Now we have two inputs, one. That is, now sum is one, but no carry. Sorry, now we have, so here actually sum is one, no carry. Now here we have carry is one, no sum. Because two means you are giving to the next level. So now no sum, but now there's a carry. Of course, when both one zero, one again, sum is one, carry is zero. This is again, carry is one, sum is zero. Again, carry is one, sum is zero. When all are one, we have both sum and carry. Okay. So if you can design this kind of a device that fulfills the truth table, of course, this is two truth tables in one diagram. And the first output must be able to sum it. Second output must be able to give you the carry out so that one column can be done. Then that column's carry out is the input to the carry in for the next left neighbor. And again, if you want, you can think of sum of product and product of some arrangements and come up with the simplest possible. That is perfect, correct? But because sum is more related to the XO operator, because SOP and POS will not give you solutions connect using XO operators. Because some operation itself is XO, right? Okay, it's basically XO. Because when they are different, one, when they are the same, zero. So therefore, you need XO. Actually, this is your half add. This is adding maybe these two. This is one of that half add. And you have the next half adder. But for that next half adder, your carry from the previous step or the immediate right column is the input to the next half adder. Right? So therefore, this is like two half adders and OR gate. Two half adders and OR gate. Okay. So this is another way of looking at it. Say I have half adder and its output is given to the other half adder, which is a XOR gate. And these carry, if you have a carry in this or that, right? If you have carry in the first half adder or second half adder, then there's a carry. Otherwise, there's no carry. And of course, this is your final sum. So when you get deep understanding, you should be able to draw it by yourself without any issue. How the full ladder is created using two half adders. Okay. Or you can just create your full ladder using your NOR gates and gates and so on. Okay. So if you need a full ladder, you need two half adders and OR gate. Final one is triple carry adder. Now remember, full ladder does the work. Full ladder can do the work perfectly. Like 101, say 101, 1 1. 1 plus 1 is 2 means giving 1, 2 means giving 1, 2 means giving 1. But you need to apply your column by column, you need to use your full ladder. This is first time for this column, next for the next column, next for the next column, and so on. Of course, that work. And you do it like this, going from right to left. So that means the first one's output is part of the input to the second time, third time. So then computer engineers, digital circuit engineers thought, so rather than you sending, say if it's a 1 byte number, you need to use it 8 times. So why don't we just have set of full ladders in a sequence? So that, because remember the first one's carry is the input to the second one, plus the numbers. So it's a chain. So then when this is executed from right to left, so you are getting the output. You are getting the output without any delay because you are basically giving addition of each column to a one particular full ladder. So this full ladder will take care of addition of this. And when this is done, this full ladder will start take caring of this and so on. Okay. So that is called ripple carry adder. So then you can do it fast because we are not going to reuse the same adder for different digits. So if we add 1 byte numbers, you need two adders connected like in a sequence manner. We call it triple carry adder. Okay. So this is another way of looking at triple carry adder. This is triple carry adder using full adders. This is triple carry adder using set of half adders and OR gates. So remember, this is half adder. This is a half adder. So half adders can add. So then when you are adding numbers, so here you get the final answer, right? Very quickly. So you're adding 1011, 101. So then you have 1 and 1. Okay. So it start from here to here. So then you have 1 and 0 and carry from previous step. And when you are here, the output is here. Okay. Ripple carry add. So ripple means wave. You may have heard ripple ice cream, ripple noodles. It's like a wave. It processes from right to end, right 10 to left. Okay. Right. So now we are done with one component, which is combinational component. This one of the easiest component. Actually, this topic is even in A-level ICT. Okay, so you can't say these are difficult. I don't know if it's difficult or easy. Examiners think that even A-level ICT student must be able to explain full ladder, half ladder. Now we move on to our next combinational circuit component decoder. So these are the toys in digital circuit, right? Decoders, encoders, multiplexers. If you don't understand these things, right, you can't understand anything about digital electronics because these are the very basic building blocks. And of course, you need to understand. Just memorizing doesn't work without understanding. Right. So remember, we just go through our structure, right? What is decoder? Why do we need decoders? How to create decoders? Right. So what, why, how? So what is a decoder? Anyone who has done digital electronic or electronic, what is a decoder? Okay. No one has done digital electronic. No, decrypt the code is not the general definition of a decoder. So you need to look at the decoder as a device. Decoder as a device. I'm not referring to something called encoding, decoding as a data processing. What is meant by decoder as a electronic component? So decoder is an electronic component having n inputs and 2 to the power n outputs. That is the starting point. So that means 2 input, 2 to the power 2, 4 outputs. Or 3 inputs, then 2 to the power 3, 8 outputs. Okay. Or 1 input, 2 to the power 1, 2 outputs. That is 1 to 2 decoder, 2 to 4 decoder, or 3 to 8 decoder, or 4 to 16 decoders, and so on. That is a step number 1. So if you want to explain decoder, first you must tell that it has n inputs and 2 to the power n outputs. Okay. N number of inputs and 2 to the power n possible outputs. So then what is the behavior? So the behavior of a decoder is for any input combination, any combination like all are 0 to all are 1, or maybe 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. So there are 8 possibilities if it is 3 input. For any combination, only one output must be 1, all the others are 0. For a different combination, maybe this is 1, all the others are 0. So if you have that kind of a component, we call it a decoder. Right? We call it a decoder. So you need to take your time, right? Because you need to do slow thinking. You can't rush these topics. So if you have that kind of a device, electronic device, digital electronic device, so we call it decoder. Okay. So that is the answer for what, right? So maybe it's 2 to 4 decoder. Maybe 0, 0, this is 1, these are zeros. Maybe 0, 1, this is 1, others are zeros. Maybe 1, 0, this is 1, others are zeros. Maybe 1, 1, this is 1, others are zeros. Okay. Is it clear? So therefore, you can have 1 to 2, 2 to 4, 3 to 8, 4 to 16 decoders. Right. So that is what is decoder. So the next thing is why? What are the usages? Right. What are the usages? Can anyone tell me a usage of a decoder, electronic decoder? I'm not talking about the information processing concept of decoding. Digital electronic decoder. Anyone who has done a bit of electronic? I hope at least some of you guys have done electronic, right? Because you are living in 2025, right? ඔගොල්ලෝ පුරාවිද්‍යාව කෘෂිකර්මය ගැන දැන් කතා කරලා වැඩක් නැහැ. සල්ලි හම්බ කරන්න ඕන. දියුණු වෙන්න ඕන. දියුණු රටවල් කියන්නේ මොනවද? South Korea, China. So they produce electronic, mechanical electronics. So why do we need decoders? What are the usages? So decoders can be used to control systems or system circuits or system components. Controlling. Remember, one of the big area in electronics is controlling. Controlling traffic light. Right? So what about now we talk about self-driving cars. Now we have the pseudo self-driving cars even in Sri Lanka, autopilot modes and so on, right? So it's all done by controlling, right? So sequentially they get the control signals, adjusting. So it's done by electronics. So that is why modern vehicles are more electronic than mechanical. So the idea is we need to enable only one output. Say we have set of outputs 1, 2, 3, 4, 5, 6, 7, 8. So we want to enable when we going through the decoder, we want to enable only one output while all the others are disabled. So you can use decoder to do that. So this is one. It's like this is green, all are red. All are red. So when this is green, all the others are red. Only one can be green at a time. So how can we send that signal? Say you have only one platform. So this is a train platform, just one platform, but there are three railway lines. Three railway lines. But all three railway lines are supposed to go through this one platform. They can't just skip it. It's a narrow place. But at a time, only one train must be allowed to enter. Otherwise, there will be collision, right? Because though we have three lines here, we have only one line. So therefore, when this is green, definitely these must be red. And when this is green, definitely the other two must be red. Otherwise, there's a collision, right? If two of those get green, then two trains enter collision. So then someone will say, okay, so then we can have some wires and electricity so that we enable this and we make these zeros. Because that is possible, right? But let's assume that, so we have 8 bulbs. Only one bulb must be green, all the others must be red. All the others must be red at a time. So how do you operate this? Now you are going to control these bulbs from 1 kilometers away. 1 kilometers away. Okay, so you control this from here. Now one possibility is you have wires like this for all eight, and assume you have the neutral. Forget about the neutral for the time being. So now when you want to enable this, what happens? This is one, this is one, this switch is on. So we have 8 switches here. All the other switches are off. So later when you want to make this on, now this switch is one, all the other switches are off. So these switches, you have 10 switches here. So you can do like that. But then assume you are into 1 kilometers away. How many for the live wires also you have? 8 into 1 kilometers, 8 kilometers of wires. 8 kilometers of wires. Remember, the moment you make this on, you want to make this off. All the others must also be off. So therefore, if you forget about the neutral, you need 8 kilometers of wires if you are 1 kilometers away. Can you do it in a better way? More cost effective. Remember, engineers try to reduce cost, reduce energy, reduce heat, right? Make it faster. So here, remember, 8 kilometers of wire. Now, what about if we have a decoder? See what happens. If we have a decoder now. Say I have a decoder here. 2 to 8 decoder. Sorry, 3 to 8 decoder. 2 to the power 3, 8. Right? So these are connected here. 3, right? 3 to 8 decoder. So then I need only 3 wires. Just 3 wires. And 3 switches. So by giving different combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So for example, when this is all zeros, this should be on, this should be on, all the others must be off. Maybe this combination, right? Only this is on, and now all the others are off. So if you can come up with a circuit like this, we call it first decoder, and all of a sudden I need only 3 kilometers of wires, not 8 kilometers. Forget about the neutral, because using these 3 lines and a decoder, I can enable one of the output at a time while all the others are disabled. So we call it decoder, right? Decoder. So it can be 1 to 2 decoder, 3 to 2 to 4 decoder, 3 to 8 decoder, 4 to 16 decoder. So it's useful, right? Because it reduce your cost, reduce material. Because if you go for 3 to say 4 to 16, 16 means 2 to the power 4. So rather than 16 kilometers of wire, you need 4 kilometers of wires. And still it does the work. but it has a very limited purpose. What is that? Only one output is 1, all the others are 0 at a time. When this is 1, all the others are, you can't enable two outputs 1. Using decoder, you can't have something like this is 1, all are 0. No. If you have that kind of a requirement, you can't use decoder. This is for a specific usage. Is it clear what is decoder is and what is the advantage? Advantage is it cut down the cost, cut down number of lines. Right. So if you are happy with that, that means you have understood what is decoder, you have understood the practical advantages of decoder. So then we'll go into how. How. So how to create 1 to 2 decoder. So 1 to 2 decoder means 1 input, 2 outputs. Because 2 to the power 1 is 2. Okay. So the idea is when this is 0, we want to make this 1, this 0. When the out input is 1, we want to make this output 1, this output 0. So we call it output 0, output 1. So there's a reason why we don't call it output 1, output 2, rather output 0, output 1. There's a nice pattern. So this is my input. These are my output. Output 0, this one, output 1. Now when you look at the circuit, you will find that you can create a circuit so that when this is 0, this is output 0, 1, output 1, 1. And when input is 1, we can create a circuit so that output 0 is now 0, output 1 is 1. So how can we create this kind of circuit? Super easy. Just you need a NOT gate. Now what happens when input is 0? When input is 0, this is 0. And this is not 0 is 1. And now this is 1, this is 0. Output 0 is 1, output 1 is 0. Correct. So then what about when this is 1? When this is 1? When this is 1? This is 0, this is 1. So that means output 1 is 1, output 0 is 0. Yes. So our requirement is fulfilled, right? So when this is 1, this is 1, this is 0. When this is 0, this is 1, this is 0. That means only one value is enabled at a time. When output 1 is enabled, output 0 is disabled. When output 0 is enabled, output 1 is disabled. But we can do it using only one input, not using two inputs. So it's a 1 to 2 decoder. This is the circuit for 1 to 2 decoder. So, so logicians, mathematicians, electronic engineers, so they came up with this circuit and they extended it to 2 to 4 decoder. 2 to 4 decoder. So now you have two inputs. So therefore, four possible combinations. 0, 0, 0, 1, 1, 0, 1, 1. And again, we give it like output 0, output 1, output 2, output 3, so that when both are 0, output 0 is 1. Because this is like the base 10, 0, base 10, 1, base 10, 2, base 10, 3. So when your input is like base 10, 3, output 3 is enabled. When your input is like base 10, 2, output 2 is enabled. When your input is like base 10, 1, output 1 is enabled. When your input is like base 10, 0, number like, right? Not really like 0, then output 0 is 1. And we can design a circuit like this. Very simple circuit we can design so that we have two inputs and four outputs. So just you need now two NOT gates and four AND gates. Earlier we needed only one NOT gate, but now you need two NOT gates, four AND gates. So similarly, 3 to 8 decoder will have 3 NOT gate and 8 AND gates. You can see there's a pattern. So now you know what is going to happen to the 4 to 16, right? 4 not gate, 16 and gate. Okay. And this is a very simple circuit. Now what happens when both are zero? I mean this scenario. So both are zero means this is zero. 0.0 is zero. Because this is zero, this is zero. So this is zero, this is zero, zero. And now this is zero. This is This one is 0 by is 1. 0.1 is also 0. What about this? This is 1, but this is 0. 1.0 is also 0. But this one you can see 0 by is 1. This is also 0 by is 1. 1.1 is 1. Now this is 1, now others are 0. So likewise, when you change to another combination, one of those will be 1, others are going to be 0. For example, if all are 1, right? So then definitely, so this is 1, this is 1, 1.1 is 1, and you will find that all the others are 0 now. So likewise, for different scenarios, only one output is 1, all the others are 0. So that means we can control these and enable only one output while all the others are 0. So therefore, this is 2 to 4 decoder, right? 2 to 4 decoder. I don't think that we have built in 2 to 4 decoding logically. Let's double check. Otherwise, we need to build by ourselves. Try online. D latch is there. Full ladder is there. Remember we did 3-bit full ladder? Ripple counter is there, but shall I show you the bit 3-bit full ladder? So this is 3-bit full ladder. These are the two XOR gates, two AND gates, and NOR gate. Right? On a simulation එකක් කරලා පෙන්නන්නම්. Okay, so this is carry in, this is AB. What happens when all are 0? All are 0, sum is 0, carry out is 0. So what happens if carry in is 0? This is carry in, and A is 1. So then sum is 1, carry out is 0. Yes, sum is 1, carry out is 0. So what about B is 1, others are 0. Again, sum is 1, carry out is 0. Okay. So what about if carry in is 1, A and B are 0? Again, okay. And අනිත් පැත්තේ එකක් ආවේ මේ rows දෙකේ ඉඳ දෙන්නම 0. So what happens when A and B are 1 but no carry in? ඔයගොල්ලෝ කියනවනේ. What happens when A and B are 1 and carry in is 0? Anyone? ඔයගොල්ලෝ මේ කතා කරන්න හරි කුල ඇටි නේද? ලැජ්ජයි. ලැජ්ජයි නෙමෙයි මේ බය ඇති නේද? දැන් තමන් ගැන තමන්ට ආත්ම විශ්වාසයක් නැහැ. දැන් semester 3 ස්ටුඩන්ට්ලා එහෙම ටිකක් කතා කරනවා. හරි? ඒකට දැන් ආත්ම විශ්වාසය ඇවිල්ලා තියෙන්නේ. ඉතුරුලා ඉන්න අය. අනිත් කට්ටිය හැරිලා දැන් තියෙන්නේ. ඉතුරු වෙන්නේ ආත්ම විශ්වාසය තියන අයනේ. And what happens when A and B are 1, each carry in is 0? So then sum is 0, carry out is 1, because 1 plus 1 is 2. 2 means 0, give me 1. Okay. Yes, sum is 0, carry is 1. If all are 1, then sum is also 1, carry is also 1. 3. 3 means keep 1, give 1. Right? So you can see it's work, right? So this is what we discuss as full ladder. So similarly, if you build a decoder, so I thought there will be a decoder also, but unfortunately there's no decoder here. So it also work. But if you want, you can build it. Right? If you want, you can build it. So you just need, this is 2 to 4 decoder, 4 AND gates, 2 NOT gates. It will take a little bit of time, right? 4 AND gates. That's why I check whether do we have built-in decoders? No, no built-in decoders. Right? 4 AND gates, 2 NOT gates. අපි AND gate එක මෙහෙම පාගමු දැනට. එහෙම බැලුවොත් ලේසි වෙයි. So then 2 NOT gates. So then you have the 2 inputs. Input දෙකයි නේද 2 to 4. Inputs are toggle switches. So then you need, yeah, that's it, right? Right, now we can connect. For this one, I will connect purely this. කෙලිම මේ දෙන්නව connect කරනවා. මේ අන්තිම එකට මම note දෙක connect කරනවා. මෙයාට මම connect කරනවා මෙයාගේ 1, මෙයාගේ not. මෙයාගේ 1. මෙයාට connect කරනවා මෙයාගේ not. මෙයාගේ pure 1. දැන් හරි. So now I need bulbs. Four bulbs. මෙයා කළා බලනකොට තේරෙනවා කරන්න නැතිව ඉතින් කරන්න බෑ ඉතින් කරන්න නැතිව ඉතින් බොරුවක් කරනවා කියන්නේ ජීවිතේ බොරුනේ සමහරුන්ගේ නේද ජීවිතේම බොරුවක් ඇත්තම සමහරුන්ගේ ජීවිත බොරු තමයි යා නිකන් ඔහේ ජීවත් වෙන බොරුයි ඉස්කෝලේ යනවා කියන්නේත් බොරුවක් වැඩට යනවා කියන්නේත් බොරුවක් ඉගෙන ගන්නවා කියන්නේත් බොරුවක් කසාද බඳිනවා කියන්නේත් බොරුවක් මොන දැන් ඔක්කොම 0 වුණා මොකද උනේ මෙයා වන් others are 0 now this is another combination you can see this is 1 others are 0 this is another combination දෙකම 1 කරාම මෙයා 1 වෙනවා you can see at a time only one value is out. One, others are 0. Okay, others are 0. So that is a decoder. දැන් මෙතන ඉඳලා යන්නේ මොනවද වයර්? මේ decode එක තමයි මේ තියෙන්නේ ආ. මෙයායින් දුර. select කරන්න බෑනේ. හරි. දැන් මෙහි ඉඳලා ඉන්නේ line දෙකයි පේනවද? line දෙකයි මෙහි ඉඳලා එන්න ඕන. හරි. මට ඕන ඒ දෙන්නව ආයි switch දෙකකින් අදින්නත් පුළුවන්. මේ තියෙන්නේ decode එක හොඳේ. මේ තියෙන decode එක. මේ button එක decode එක. decode එකට connect කරන්න බෑනේ. මෙතන connect කරන්න පුළුවන්. බෑනේ. මොකද මේ දෙනවා අදිනකොට ඔයාගේ මේ ලයින් තුනක් ඇදෙනවා. එහෙම ඇදෙන්නේ නැහැ ඇත්තටම. හරි. එතන දාන්න වෙන්නේ අපිට එතනට දාන්න වෙන්නේ මෙයාව කනෙක්ට් කරන්න දෙන්නේ නැහැ. මෙයා වෙනම component එකක් විතර එන්න ඕන decoder කියලා. නැතුව අඳින්න බෑ මට හරි. But you can see that if we can connect this to this rather than this, okay? And if you can connect this to this, so then here you have only two lines, but we have four outputs. Right? Likewise, 3 input, 8 output. Okay, so that is called decoder. Right? Any questions about decoder? Because it's all about confidence, right? Not memorizing, not passing exams. So it doesn't matter whether you get an A for computer system, A for programming. It doesn't matter, right? What matters is, have you understood? Have you got the competency, skill, attitude? So then you will get jobs, then you will get opportunities, then you will start doing things. Your BIT degree A level results is not going to do anything for you. දැන් ඔක දැනගත්තාම තමයි ඔය Facebook එකේම A level research sheet දාන්න පටන් ගත්තේ. මොකද ලෝකෙ වෙනස් වෙනකොට මිනිස්සු ෆ්‍රස්ට්‍රේට් වෙනවා. මිනිස්සු ෆ්‍රස්ට්‍රේට් වෙනවා. අනේ අපේ A level certificate එකට දැන් කවුරුත් ගණන් ගන්න නැහැ නේ. ගණන් ගන්න 7-5කට ගණන් ගන්න. මම නම් පිච්චියට ගණන් ගන්න. කෙල බිදක් තරමක් ගණන් ගන්න. ඩිග්‍රී සර්ටිෆිකේට් ගණන් ගන්නෙත් නැහැ. A level O level 37 ගණන් ගන්නෙත් නැහැ. දැන් ඔයගොල්ලන්ට කරන්න පුළුවන් එකම දේ තමයි Facebook එකේ දාන්න පුළුවන් මෙන්න මගේ රිසර්ච් ෂීට් එක. මං පොරක්. ඇයිද වෙන කරන්න දෙයක් නැහැ නේ. වෙන එකකින් ගන්න වැඩක් නැහැ දැන් නූතන සමාජයේ. නූතන සමාජයේ වැඩ ගන්නෙම නැද්ද? ස්කිල්ස් වලින්, කම්පිටන්සිස් වලින්, ඇටිටියුඩ් වලින්. රිසර්ච් ෂීට් වලින් ගන්න වැඩක් නැත. දැන් ඒක තමයි පිස්සු බල්ලෝ වගේ ඇදලා ඒ රිසර්ච් ෂීට් දාලා යන්නේ. ටීෂර්ට් ඉඳලා දානවනේ. ෆ්‍රස්ට්‍රේට්. වෙන ගන්න වැඩකුත් තියෙන්නේ නැත්ද බෑ. That is why we interview and take people down. Check your attitude, check your competencies. Okay. Right. So similarly, we can build 3 to 8 decoders. Same concept, right? 4 to 16 decoders, 5 to 32 decoders, and so on. And it's a control circuit, control component. Controlling is very important in digital electronics. That is why we have another engineering field called mechatronics. Mechatronics. So first came the mechanical, then electrical and electronic. Then the mechatronic. So then what is this mechatronic? Mechatronic means mechanically we generate power or whatever, do the things, but control electronically. Because electronic controlling is much reliable. Much reliable. Right. Our next device is multiplexer. Multiplexer. Now again we go through the same sequence. What is a multiplexer? What are the usages? Why it is important? And how to build a multiplexer. Okay. So what is mean by multiplexer? Multiplexer. So multiplexer is in the digital. Okay. So if I give you an analog example, analog electronic example, if you take your radio or TV, let's take radio, normal radio, right? Normal radio, not digital thing, analog radio. So you know that, say you are having a small radio set. So you are getting the series or whatever, I don't know what are the frequency ranges, right? City FM or whatever, Suryan FM or Iru FM or whatever. All these signals are coming to you. Actually, your radio set get all the signals at a time. But at a time, you want to listen to one radio station, right? Maybe now you want to listen to Sun FM. So you get multiple signals, but only the Sun FM's radio signal is sent to the speaker so that you can hear. So later you want to change it to Cirrus. Now you don't send this FM signal to the speaker, rather this signal to the speaker. So now you listen to that. That is called you tune to that particular frequency. So that means other signals you ignore, but this signal you accept. හැමෝ සිග්නල් එකක් වෙනවා. හැබැයි අනිත් සිග්නල් ඉග්නෝර් කරලා මේ සිග්නල් එක විතරක් අතුට ගන්න. Okay. So when your radio set is off, switch off, you don't take any of these signals, you just ignore them. Ignore කරාට ඔයාගේ ඇඟේ හැප්පෙනවා ඊට සිග්නල් එක. හැප්පුණාට ඔයා ගණන් ගන්න. හැමෝම හැප්පෙනවා. හැබැයි එක්කෙනෙක් විතරයි attention දෙන්නේ එකපාරට නැත්නම් එකටවත් attention නොදී ඉන්නවා අහක බලාගෙන. That is called multiplexer. But that is analog multiplexer. But idea behind multiplexer is the same. In digital electronics also, the idea behind multiplexer is same. So now we have 2 to the power n input. 2 to the power n input, say n is 2, then 4 inputs, and only one output. Now always it is one output. So therefore it can be 2 to 1 multiplexer, 3 to 1 multiplexer, 4 to 1 multiplexer, 5 to 1 multiplexer, and so on. So 4 to 1 means you get 4 signals and one of the signal is your output signal. So you ignore the other signals. At a time, only one input is in the output. Other signals, we don't care. We ignore. So say right now, this is your output now. Maybe later, this is the output. So this is 0, 0, 1, 1. This is 1. This is just a signal, right? Incoming signal. So maybe right now this signal is my output 0, 1, 1, 1. Maybe here this is my 1, 1, 0, 0, 1, 1. It's keep coming. And that is my current output. We ignore these signals. Signals are coming. But this input signal is my output signal. If you can do like that by electronic component, we call that component as a multiplexer. Is it clear? It's 2 to the power n to 1. 2 to the power n to 1. But this is not enabling. This is more serious stuff. කලින් කරේ එකක් 1 වෙලා අනිත් එක 0 වෙනවා. දැන් එහෙම නෙමෙයි සිග්නල් එක තමයි දිගින් දිගට මෙතන යන්නේ. ඒක හරියට මෙතන තියෙනවා වතුර පයිප් හතරක්. මෙතනින් තියෙන එක පයිප් එක. ඒතර ආගාව තියෙනවා මෙතන කරාම ටිකක්. හැබැයි ඔක්කොම අන්තිමට මේකට කනෙක්ට් කරලා තියෙනවා. එක වෙලාවකට අපි හිතමු මේකේ තියෙන ස්ප්‍රයිට්, ෆැන්ටා, කොකාකෝලා කියලා එක වෙලාවකට මේකෙන් එන්නේ එකයි. මෙතන දැන් සාමාන්‍ය නේවයි තියෙන මේවා හතරක් තියෙන්නේ නැහැ. එක කරාමයි තියෙන්නේ. ඔය එක වෙලාවකට වාට කෙනෙක් කියනවා මේකෙන් කොකාකෝලා ඉන්න ඕන. අනිත් ඒවා ඉන්න බෑ. ඒතකොට අනිත් ඒවා ඉන්න බෑ. මික්ස් වෙන්න බෑ. දිගටම කොකාකෝලා ඉන්න ඕන දැන්. Continuously you are getting Coca-Cola as the output, but only one output valve. Or by some control mechanism, you make sure that only you are getting Sprite until you stop and change it to something else. Okay. So that is same concept. एक मतलब आप radio एक करने, but this is now digital signal. Digital signal only make කරන්න පුළුවන්. ඇනලොග් සිග්නල් වල හරිය ලේසි නේද? ඒ ෆ්‍රීකවන්සි මේගොල්ලෝ එන්නේ එක එක ෆ්‍රීකවන්සි වලනේ. සිරස් එන ෆ්‍රීකවන්සි එකේ නෙමෙයි සන් FM එක. හිරු එක. ඒ කියන්නේ ඒකට වෙන වෙන ෆ්‍රීකවන්සි තියලා තියෙන්නේ. 88.8 එහෙම කියලා තියෙන්නේ. So our device our radio can filter only that frequency. So that means that frequency signal is going out, other frequency signals are ignored. So that is called filtering signals. Analog signal filtering. So there are analog electronic devices. But here we do it like a logic. Actually, this is very easy to understand. But this is very interesting one. මේක ඊටට හිතා ගන්න අමාරුයි. හැබැයි වැඩේ පට්ට interesting. අමාරු දේවල් කොහොමද ඉතින් interesting වැඩි ඉන්නේ. ඔයගොල්ලෝ හිතා ගන්න පුළුවන්ද මේක මොකද කරන්න පුළුවන්ද? සර්කිට් එක හදා ගන්න පුළුවන්ද? පාටි කොත්තේම දැන් මේ වෙන සර්කිට් එක හදලා දෙන්න කියලා. මේකෙන් දැන් 10011 මේ රැන්ඩම් සිග්නල් එක. අනිත් ඒවායිත් එක එක සිග්නල් එනවා දැන් හරි. ඔයා මොකක් හරි මේ කන්ට්‍රෝල් සිග්නල් එක යූස් කළා. ඒ කන්ට්‍රෝල් සිග්නල් එකේ අපි 00 කම්බිනේෂන් එකේදී මෙයා තමයි යන්න ඕන අවුට්පුට් එක. 01 එකේදී මෙයා අවුට්පුට් එක යන්න ඕන. 10 එකේදී මෙයා යන්න ඕන. 11 එකේදී මෙයා යන්න ඕන. අනිත් ඒවා ඉග්නෝර් වෙන්න. හදන්න පුළුවන් සර්කිට් එක. So using logic gates. දැන් නිකමට ඉතින් ඒ දවස්වල 1960 ගණන් වල 50 ගණන් වල මේවා හදපු මිනිස්සුනේ නේද? ඉංජිනේර්ස්ලා නේද මේවා? So they thought. So when the AND gate, OR gate, those concepts are developed, so then all of a sudden they start thinking about how to play with these things and do some interesting things, important things, productive things. So that is what engineers do, right? So engineers build things. Engineers build things. And of course, they managed to build the circuit for that. And now we call this multiplexer. So this is what the multiplexer is doing, right? Say now, say when this is 00, this one is your output. Make a output. Yeah? So your output is now I0. When this is 01, your output is this input. When this is 10, your output is this මේ line එකේ input එක තමයි output එක යන්නේ. මේකේ output එක යන්නේ. When your control signals has 1, then this is your output. Okay. එතකොට typing mistake එකක් තියෙනවා මේක I0, I1, I2, I3 වෙන්න ඕන. මගේ අත ඒක වෙනස් වෙලා නැහැ. Let me fix it නැතව අමතක වෙනවා. මේක I1. So this should be I2. And this should be I3. Now it is correct. I put a mistake at no typing mistake. So your output is either I0, I1, I2, or I3. How do you control? That is why we have two more inputs. These are your data input. These are your controls. Control are also digital. Data is also you are getting digital. So if you can develop this kind of a circuit, we call it multiplexer. Digital multiplexer, because analog multiplexer is something else. Where we filter by frequencies and so on. And this is how you build a 2-to-1 multiplex. You don't need to memorize this circuit, but this is for your confidence. Multiplex එකක් හැදෙන විදිය දන්නේ නැති වුණාම ඔයාට නිකන් එහෙම confidence එකක් එන්නේ නැහැ නේද? අනිත් අය දන්නවනම් අනිත් කම්පියුටර් ඉන්ජිනියර්ස්ලා කම්පියුටර් සයන්ටිස්ට්ලා IT කරන අය දන්නවනම් ඔයා දන්නේ නැත්නම් මල්ටිප්ලෙක්ස් එකක් යනවාට නිකන් මහ විලි ලැජ්ජාවක් නේද? ඔයාට ඒකට බයක් හිතෙනවනේ එතන ඉන්න. ඒගොල්ලෝ ඉන්නකම් එහෙනම් දැන් ඔය BIT ඩිග්‍රිය ගන්න හැමෝම ජොබ් වලට CV දාන්නේ නැහැ හරි. ඒක සොඳ මතේ තියාගන්න. අපි මේ ඩිග්‍රිය ගත්ත කියලා 200ක්. දැන් මේ 200ම ජොබ් වලට ඇප්ලයි කරනවද? අපෝ නැහැ. සමහර ජොබ් එකක් දැක්කට මොකද ජීවිතේට CV එකක් දාන්න. පණ බයයි CV දාන්න. ඇයි ඒ? එතන ගියාට පස්සේ නෝන්ඩි වෙයි කියලා බයයි. ඒතර එතනට එන්නේ ඩිග්‍රී තියන අයනේ. ඔව් එතනට එන්නේ ඩිග්‍රී තියන. ඒකට ඔයාලට බයයි. කියනවා කම්පිටන්සි බිල් කරගත්තේ නැහැ. කම්පිටන්සි බිල් කරගත්තේ නැහැ. එක්සෑම් පාස් කරා. කටපාඩම් කළා. ඒකට ඉතින් ජොබ් වලට ඇප්ලයි කරන්න බෑ. ඇප්ලයි කරනවා හිත දෙන්නෙම නැහැ. ඇප්ලයි කරත් ඉන්ටර්වයුව ආවා කෝල් කරා කියමු. ඒ පාර කපන යනවද නැද්ද? මම නෝන්ඩි නොත් ඉන්ටර්වයුව එකේදී. නෝන්ඩි වෙන්නේ නැහැ මම දන්නේ නැහැ. මිනිස්සු නෝන්ඩි කරන් ඉන්ටර්වයුව වලට එන්න කියන්නේ නැහැ නේද? එන්න කියන්නේ හොඳ මෙක්කනව තෝරගන්න. දෙතුන් දෙනාම. Right. So this is, if you develop this kind of a circuit, you don't need to memorize this. You just need to understand. That's all. This act or this work as 2-to-1 multiplexer. 2 input, 1 output. And you need 1 control signal. So therefore, there are 3 inputs. Your 2 data signals and control signal. Your 2 data signals and control signal. These are the input. Control signal is also considered as input. And your output. Your output. And if you take any combination like this is 0, this is 0, this is 0, that means 0, 0, 0. Right? 0, 0, 0. So then what happens? So this is 0 means this is 0, this is 0, this is 1, 0.1 is 0, 0.0 is 0, 0 or 0 is 0. Okay, okay. Now let's take something like 0, 0, 1. Control is 0. I0 is 1. I1 is 0. Then one go then. So this is 1. This is 1. 1.1 is 1. This is 0. This is 0. 0.0 is 0. 1 plus 0 is 1. Yes, output is 1. ඔන්න ඔම combination වල මේක fill කරන්න. You will get this output. Right? You will get this output. And if you analyze this truth table now, analyze, you will find that your output is same as I0 when your control signal is 0. And your output is same as input 1 when your control signal is 1. So when your control signal is 1, whatever the I1 is your output. When control signal is 0, whatever the I0 is your output. So whatever මෙහෙම එන signal මොනවා වුණත් ඔයාගේ I0 එකේ signal එක තමයි output එක ඊළඟට යන්නේ. So therefore this will be your output when control is 0. This will be your output when control is 1. So that means it's multiplexer. You can decide which input is your output. How? By controlling this control signal, whether it's 0 or 1. So that is a 2-to-1 multiplexer. Again, don't memorize the circuit. Right? Just know what is it. අවුත් කියනවනේ මෙන්න මේක තමයි මල්ටිප්ලෙක්ස් එකක් කියන්නේ මම දන්නා මොකද්ද වෙන්නේ කියලා. සර්කිට් එක කටපාඩම් කරන්නේ නැහැ මම. මට බොළුවේ අමාරුවක් නැහැ. දැන් මම දන්නා මොකද්ද මල්ටිප්ලෙක්ස් එකකින් වෙන්නේ. මම ඕනනම් ඉන්ටර්නෙට් එකකින් ඩයග්‍රෑම් එකක් සර්ච් කරලා අරගෙන ඔයාලට එක්ස්ප්ලেইন කරන්නම් A to Z මල්ටිප්ලෙක්ස් එක කියන්නේ මොකක්ද කියලා. That is enough. That is enough. You don't need to memorize this. අපි ගේම් ගහන්නේ කටපාඩමින් නෙමෙයි. අපි ගේම් ගහන්නේ බුද්ධියෙන්. ඒක අපේ අධ්‍යාපන ක්‍රමයේ තියෙන ලොකුම කාලකන්නිකම ලංකාවේ ඉන්න බමුණු හිතන් ඉන්නේ කටපාඩම් කරපුවා මතකද කියලා බලන්න ඕනේ කියලා. නෑ. කටපාඩම්ද කියලා බලන්න දෙයක් නෑ. මොකද ඉස්සර කටපාඩම් ඉන්නේ දැනුම ගියේ ඊළඟ ජෙනරේෂන් එකට. අපේ ඉන්න බමුණු හිතන් ඉන්නේ තාමත් දැනුම යන්නේ කටපාඩමින් කියලා. වන පොත් කරලා. කාලකන්ණි බමුණු. මොකද උන් වෙනස් වෙන්නේ නැහැ. හරි ප්‍රයෝජනවත් වැඩ කරන මිනිස්සු කටපාඩමින් නෙමෙයි වැඩේ කරන්නේ බුද්ධියෙන් ඇටිටියුඩ් වලින් ස්කිල්ස් වලින් ඒගොල්ලන්ට ඕන්ලාගේ chat GPT ඉන්නවා ඉන්ටර්නෙට් එක තියෙනවා සර්ච් එකක් දාලා අරගෙන රීයුස් කරලා අපිට තියෙන ඇසෙම්බල් කරලා වැඩේ කරලා දෙන්න හරි අපිට තියෙන මල්ටිප්ලෙක්සර්ස් එන්කෝඩර්ස් ඩිකෝඩර්ස් එකතු කරලා මොන හරි ප්‍රයෝජනවත් දෙයක් හදන්න so that is our task that is the engineer's task not memorizing the circuit of a multiplexer multiplexer කියලා search කරලා multiplexer කියනවා හැබැයි දරගන්න මොකද්ද multiplexer එක වෙන්නේ කියලා okay right so any questions so similarly that is 2-to-1 multiplexer we can build similarly 3-to-1 multiplexer sorry 4-to-1 multiplexer 4-to-1 then you need 2 control signals so similarly we can have 8-to-1 multiplexer then you need 3 control signals and so on okay ඔයාලට මෙන්න මේ විදිහට truth table එක ඇඳ ගන්න පුළුවන් නෑ මැති right මේ විදිහට නේද So you can see when both are 0, your output is I0. When this is 0, this is 1. This is like base 10 0, base 10 1, base 10 2, base 10 3. When 0 1, I1 is your output. I1 is out. When this is 1 0, it is like 2, then I2 is your output. When this is 1 1, it is like base 10 3, I3 is your output. ඔන්නෝක තමයි අර සර්කිට් එකෙන් වෙන්නේ. හරි. අර සර්කිට් එකෙන් වෙන්නේ. එක එක අරන් බැලුවොත් ඕක තමයි වෙන්නේ. Okay. Therefore, it's always one of the input is your output depending on your control signal combination, whether it's 0 0 0 1 1 0 1 1. දැන් මේක උත්තර හදලා බලන්න. AND gate හතරකුයි OR gate එකකුයි දාලා NOT gate දෙකකුත් එක්ක මේ එක එක සිග්නල් මෙතන වල සිග්නල් සීරීස් එකක් එවන්න ඕනේ දැන්. 1 1 0 0 එහෙම කියලා සීරීස් එකක් එවන්න නැතුවට මේක තේරෙන්නේ නැහැ. සිමියුලේට් කරන්න බෑ. හරි. බලමු සිමියුලේට් කරපු එකක් තියෙනවද කියලා කොහේ හරි ඉන්ටර්නෙට් එකේ. Say digital multiplex simulation. තියනවද දන්නේ නැහැ. තියුණොත් බලමු. Say 41 multiplex. ටිකක් බරපතල එකක් තියෙන්නේ හැබැයි යා. control signal වෙනස්කම් දෙනවද? නෑ නේ මෙයා instructions. මේක ටිකක් බරපතල multiplex එකක් තියෙනවා. දැන් ඔයගලන්ට හිතෙන්න පුළුවන් දැන් ඔයගලන්ට හිතෙන්න පුළුවන් මේ අපි කරන එක පට්ට අමාරුයි කියලා. ඒත් මේව මොනවද? මේක ඉලෙක්ට්‍රොනික ඉංජිනේර්ස්ලා ඉගෙන ගන්න. හරි. මොකද සමහර විට මේ අපි කරන දේවල් මාර අමාරුයි කියලා. ඒතර මොරඩෝ කැම්පස් එකේ පේරාදෙනී ඉලෙක්ට්‍රොනික ඉංජිනේරින් කරන කෙනෙක්ගෙන් අහලා ඒගොල්ලෝ කිව්වේ මේ මොනවාද මේ උඹලා කරන්නේ බීරුනේ කියලා. පොඩි උන් වගේ විහිළු කර කර ඉන්නේ මොනවාද කියලා. අන්න ඒක තමයි කියන්නේ මිනිස්සුගේ කැපැසිටි එක කියලා. හරි. දැන් ඔයාලට බැට් එකකුගේ පෑඩ් එකක් දාලා යවුවොත් ඒ පිට්ටනිය මැදට බහිනවන්නේ දරුන් ගහන්නේ කාලා ගන්නේ ඇත්ත මැච් පරදිනවා. හරි. දැන් ඔයාලට පෑඩ් එක දාලා යවන්න ඕන. එහෙනම් උඹලා ගහපල්ලා අපිට බයින් බැඩමැන ඉන්නේ කියලා. එතකොට තමයි තේරෙන්නේ කොච්චර වැඩේ අමාරුද කියලා නේ. හරි ලිම් ගහන්න නැත්නම් ඒක වැරද්දයි. දැනගන්න එපා ඉන්ටර්නැෂනල් ලෙවල් එකට ගිහලා ක්‍රිකට් ගහන්න. ඒක වෙනම කතාවක්. නමුත් ඒ ලෙවල් එකට අපිට ගහන්න බෑ නේද? ඒ වගේ තමන් කැපැසිටි එක හදා ගන්න. හදාගන්න පුළුවන්. හැමදාම මම සූටීනේ තාම පොඩි කිය බබා හුකුම් එන්නේ නැතු. Right. So that is now we have discussed adder, decoder, multiplexer. So the last one is encoder. දැන් මම හොඳට මතකයි අපි කරන්නේ ලේසි ටික. මොනවාද ලේසි ටික? Combinational circuits. අමාරු ටික තියෙන ඊළඟට. මොනවාද? Sequential circuits. right මේ වගේ පස් ගුණයක් විතර අමාරු sequential circuit තේරුම් ගන්න. તો තේරුම් ගත්ත කියන්නේ මොකද්ද? ඔයා capacity එක ඊළඟ level එකට ගියා. ඊළඟ level එකට ගියා. ඔයාලට පුළුවන් තව කාට හරි ගිහලා පෙන්නන්න මොනවද උඹලා ඉගෙන ගන්න. උඹලට එන්කෝඩර් එකක්වත් තේරෙන්නේ නැද්ද? ඩිකෝඩර් එකක්වත් තේරෙන්නේ නැහැ. එහෙම තමයි ඉතින්. එක එක levels. Right. So what is encoder? You can see the word is somewhat similar to decoder, right? Decoder, encoder. ඒතර කාට හරි හිතන්න පුළුවන් ඩිකෝඩර් කරලා එකපාරට එන්කෝඩර් කරේ නැතුව මේ මල්ටිප්ලෙක්ස් එකක් අස්සට දැම්ම කියලා. ඒකට හේතුවක් තියෙනවා. නම එක වගේ වුණාට කරන වැඩේ ටිකක් වෙනස්. පොඩි සමාන ගතියකුත් තියෙනවා නමුත් කරන වැඩේ ටිකක් වෙනස්. And also this is even more challenging to understand. That is why we take it last. So this is even a little bit more mysterious device to understand. Right? If you don't understand it properly, you will not understand what is encoded. Okay. Right. So remember decoder, you have n inputs, 2 to the power n output. Right? 2 to the power n output. And only one output is 1 at a time. All the others are 0 for a particular combination. That is decoder. N inputs, 2 to the power n outputs. In encoders, we have 2 to the power n inputs and n outputs. Say 4 inputs, 2 outputs. Calling 2 inputs, 4 outputs. Calling 3 inputs, 8 outputs. Now 8 inputs, 3 outputs. So therefore, you can see it's like the mirror image. So therefore, the word like it looks like suitable, right? Decoder, encoder. ආයිත් වල ඉගෙන පුළුවන් ඉතින් එන්කෝඩ් එක ඉගෙනගෙන එපා ඩිකෝඩින් කරන්න නේද සාමාන්‍යයෙන් අපි කියන්නේ එන්කෝඩ් ඩිකෝඩ් හැබැයි පටන් ගත්තේ කොහොමද ඩිකෝඩ් එන්කෝඩ් ඒකත් හේතුවක් තියෙනවා ඇයි ඩිකෝඩ් එක තේරුම් ගන්න ලේසි එන්කෝඩ් එක තේරුම් ගන්න ටික අමාරුයි හැබැයි රිවර්ස් තමයි එක්තරා විදිහකට at least the arrangement is reverse so encode is 2 to 4 sorry decoder is 2 to 4 encoder is 4 to 2 you have 2 to the power n input n output දැන් කලින් නම් කියන්නේ වයර් ඉතුරු නැග දැන් මේ වයර් විනාශ කරනවා දෙකකින් කරන්න ඕන වැඩ හතරකින් නෑ මේකෙන් කරන්නේ වෙන වැඩක්. This is a different encoders are for different purpose, not for the same purpose as decoder. And the purpose is also not the reverse of the decoder. Though the circuit or the arrangement looks the mirror image, the usage is not the reverse of the decoding. Okay? It's a different usage. And encoders has different usages also. But the starting point is yes, encoder has 2 to the power n inputs and n outputs. Like 2 to the power 2 or 4 inputs, 2 outputs. For 2 to the power 3 or 8 inputs, 3 outputs. So that is the step number 1. Okay. And now there's another restriction. Only one input line must be enabled. So only one input must be enabled. Others must be disabled. So when this is 1, others must be 0. That is also okay, right? Because in decoder, only one output is 1. Now only one input is 1. Right? So far, so good. Right? It's like the reverse. So then let's look at the usages. මම තාම output එක මොකද වෙන්නේ කියලා කිව්වේ නෑ බయ్యා. කලින් නම් input එකට මෙහෙම output එකක් වෙනවා කියලා කිව්වා. දැන් මම output එක වෙන්නේ මොනවද කියලා වෙන්නේ ඇයි ඒ? So it depends on the type of encoder. So there are quaternary to binary encoders, octal to binary encoders, hexadecimal to binary encoders, priority encoders, decimal to BCD encoders, and so on. Because encoders have different usages and slightly different type of encoders. But we will look at only one type of encoder just to give you the feeling of what is a possible usage of encoder. Because we don't go into details because our subject is not digital electronic engineering. Let's engineering students learn that. Right? We are not doing electronic engineering, we are doing IT. But we must have that basic understanding so that you have a little bit of understanding about what they are doing, right? How the electronic components work in computer. Right. So this is an example of 4 to 2 or quaternary to binary. Another name for 4 is quaternary. Right. 2 to the power 2, which is 4, and this is 2, correct, right? 4 to 2. So if you have 4 to 2 encoder, you can convert base 4 number to base 2 number. That is why we say quaternary to binary. Base 4 number, you can convert to base 2 number. Number conversion. Number base conversion. So therefore, this is more than control. This is a processing circuit. Number conversion can processing control එකට වඩා. So you can convert base 4 number to base 2 number. Base 4 කියන්නේ you digit 0, 1, 2, 3 විතරයි තියෙන්නේ. Okay. Okay. And these are your 4 inputs. These are your 2 outputs. When this is like 1, then බලන්න අපෝ. මේක නිකන් 1 වගේ මේක නිකන් 2 වගේ. මේක නිකන් 3 වගේ. මේක නිකන් 4 වගේ. මේක 4 නෙමෙයි. මොකද දෙකේ පාදේ මේක ගත්තොත් 1, 2, 4, 8 වෙන්න ඕන. This is I3, I2. Sorry. This is I0. This is 0. This is 1. This is 2. This is 3. I0, I1, I2, I3. And you can see when I0 is enabled, remember only one value can be 1, others are 0. Your output is like base 2, 0. Meaning දෙකේ පාදයෙන් බිඳුව. When I1 is 1, this is base 2, 1. 0, 1 is 1. When I2 is 1, this is in base 2, 2. Because 1, 0. 1, 0 can be 2. 2 to the power 0, 2 to the power 1. When only I3 is 1 and others are 0, it is like 1, 1. 1, 1 means these are 1s, these are 2s, 2 plus 1, 3. So when this is 0, this is 0. When this is 1, this is binary 1. This is 2, this is binary 2. This is 3, binary 3. So if you can build such a digital circuit, we can call it 4 to 2 or quaternary to binary encoder. Convert your quaternary number into a corresponding binary number. And this is how you develop it. It's very easy. It's very easy, but it's mysterious. ඒක හරි ලේසි. ඕකේට් එකක් විතරයි තියෙන්නේ. හැබැයි සමහර දේවල් ලේසි හැබැයි හරි গুপ্তයි. গুপ্තයි. මේක গুপ্ත සර්කිට් එකක් එකපාර වැටුවා. ගැඹුරට හිතුවේ නැත්නම් গুপ্তයි. හොල්මනක් වගේ. So remember we have 4 input, right? I0, I1, I2, I3. Yes, we have 4 inputs. And we have 2 outputs. Yes, output 0, output 1. මොකද්ද මේකේ තියෙන গুপ্তකම? මෙන්න මේකව කනෙක්ට් කරලා නැහැ. ඒක ඔහෙ ඉන්නවා. ඒක ඔහෙ හිටියට මොකද ඔහෙ ඉන්නත් ඕන. දැන් ඒක අයින් කරන්න බෑ. හරි? අයින් කරන්න බෑ concept එක තේරුම් ගන්න. දැන් මෙහෙම වයර් එකක් ඕනේ නැහැ. මොකද නිකන් වයර් එකක් මෙහෙම කරාට සර්කිට් එකකින් කළා නැහැ. උඩකින් ඉලෙක්ට්‍රෝන යන්නේ නැහැ. But in order to explain quaternary to binary, you need this input. Okay. Now this is I2 plus I3. And this is I3 plus I2. Sorry, I3 plus I1. And I0 is not used for any of the circuit outputs, right? I0 is not considered for the output. And this is your quaternary to binary encoder. ඒක හරි කියලාට දෙන්න. So let's say 0, 0. Sorry, 0, 0, 0, 1. On our input combination. I0 is 1. These are 0. Now what should be the output? 0, 0 another one. So this is 0 and 0, 0, 0. This is 0, 0, 0, 0, 0. Yes, 0, 0. Yeah. Now let's take that second row. This one. I0 is 0. I1 is 1. I2 is 0. I3 is 0. 0 plus 0, 0. 1 plus 0, 1. O0 is 1. Yes. O1 is 0. Yes. 0 0 1 0 0 0 1 0 0 plus 1 1 0 plus 0 0 that means 0 is 0 1 is 1 එකත් හරි එකත් හරි කියන්නේ මෙයා මේන් බැලුවොත් එම් බයිනරි වලින් බැලුවොත් එම් 1 0 is 2 yes 2 let's look at the last one 0 0 0 1 1 or 0 is 1 1 no 0 is 1 ඔය ආයේ 1 1 කියලා ඒකත් හරි හරි so you can see in order to explain this you need this I0 though I0 is not connected right because I0 is 1 මේකද I0 1 වෙලා අනිත් අය 0 වුණාම තමයි මේ ඔක්කොම දෙන්නම 0 වුනේ හරි අනිත් තැන් වල I0 0 තමයි තියෙන්නේ ඒකන කොහොමත් එතන අවුලක් නැහැ හැබැයි මේක I0 1 වුණාට මෙතන ආවේ 0 0 කියලා හරි කල්පනා කරලා බලන්න කල්පනා කරලා බලන්න ඔය වගේ අපිට වෙන වෙන කම්බිනේෂන් හදන්න පුළුවන් coordinate binary එක වගේ හරි octal to binary hexadecimal to binary encoders we can build right again you don't need to memorize these things but නේද මම කිය සමාජයට ගියාම ඉන්ජිනියර්ස්ලා ඉන්න තැනකට ගියාම ඔයාලට එන්කෝඩ් එකක් කියන්නේ මොකද්ද කියලා නිකන් තේරෙන්නේ නැතුව ඉන්න බෑ. එතකොට ඔයාලට ඉන්ටර්විව් එකට ගියත් බය අල්ලපු එක එන්කෝඩර්ස් ගැන දන්නා මම දන්නේ නැහැ. සමාජයට ගියාට පස්සේ කැමති නම් නැතත් තරගයක් තියෙනවා. හරි. ඒතර ඔයා දැනගන්න ඕන ඔයා සෙට් වෙන තැන ගිහිල්ලා තරග කරලා එතනින් සතුටු වෙන්න. ඔයාලට එතනින් එහාට තරග කරන්න බැන නවත්තන්න. ඔයා ඒ ලෙවල් එකේ ඉන්න. ඒකට ඔයාලට කාටවත් බයින්න බෑ. ඒකට සමාජවාදය ඇති කරලා මාක්ස්වාදය ඇති කරලා බෑ. කේක් කෙනා ඉපදෙනකොට පොටෙන්ෂල් වෙනස්, ඇටිටියුඩ් වෙනස්. හරි. ඒතර මේ වෙලාවේ software engineersලා ඉන්නවා ලක්ෂ 10 15 පඩි ගන්න. project managersලා ඉන්නවා ලක්ෂ 15 පඩි ගන්න. එතකොට ආයේ ඒක ගැන ඉරිසියා කළ වැඩක් තියෙනවද? එතකොට ඒක ගියා එන මගේ ඇවිල්ලා මගේ වැඩේ කරන්නකෝ. මං ලක්ෂ 15 ඔබ ගනි. මාස 3ක් දෙන්න ඔබට. මම මාස 3ක් නිවාඩු වෙනවා. මට ඕන තරම් දැන් සල්ලි තියෙනවා ඔයගේ දවස් ටික මම මාස 3ක් නිවාඩු වෙනවා. ඔබට ලක්ෂ 15 ගනි ආවම මගේ වැඩේ කරලා යනවා. එතකොට නැට්ට අකුලගෙන ගෙදර යන්න තමයි වෙන්නේ. හරි? නැට්ට අකුලගෙන ගෙදර යන්න තමයි. මොකද සමහර ඉතින් ඉන්න මේ ජනාධිපතිකම් කරනවා වගේ, മന്ത്രിකම් කරනවා, ඇමතිකම් කරනවා වගේ ලේසි එකනේ ඉංජිනේර්ස්ලා වෙන්නේ. හරි? එච්චර ලේසි නෑ. හරි? බොරුවෙන් ඉංජිනේර්ස්ලාට ජීවත් වෙන්න බෑ. බොරුවෙන් නේද? අපි ගිහලා බොරු කිව්වයි කියලා software develop වෙන්නේ නැහැ, system හැදෙන්නේ නැහැ. ඒක ඉංජිනේර්ස්ලාගේ අනිත් අයගේ තියෙන වෙනස. whether it's software engineer, computer engineer, system engineer බොරු කරන්න බෑ අපිට ගිහිල්ලා. බොරු කරා කියලා ප්‍රතිඵල ලැබෙන්නේ නැහැ. අනිත් අතට වැඩේ හරියට කරොත් හරි ප්‍රතිඵල ලැබෙනවම තමයි. Right, so that's it about combinational circuits. Okay, so these concepts can be combined when we develop our microprocessors. For example, when it comes to memory handling, so we use decoders because we want to, at a time, we want to access a particular memory address. But say it's 1 GB memory, නිකම්ම හිතන්න 1 GB memory එක 1 GB නෙමෙයි දැන් අපේ තියෙන 16 GB 32 GB. Okay, say let's assume 1 GB memory and each memory location has one byte. What is how many memory locations are there? Kilo is 2 to the power 10, kilo mega is 2 to the power 30. memory location කොච්චරක් තියෙනවද? 230ක් තියෙනවා. memory location තියෙනවා මේ 0 1 2 3 කියලා 230ක් තියෙනවා. එක බයිට් එක ගන්න ගත්තොත් ඒ 1 GB නම් හරි 32 GB නම් තවත් 234ක් විතර වෙනවානේ 230ක් කියන්නේ කොච්චරක් කියලාද ඕලි හිතන්න 230ක් කියන්නේ 2 to the power 30 මේ බිලියන කීයක්ද මෙන්න මිලියන 3යි මෙන්න බිලියනයයි මිලියන 73කුත් තියෙනවා 1 billion and 73 million memory locations. ඒ ඇයිල 1 GB නම් හරි. මේ 1 billion 73 ලොකේෂන් වලින් එකට තමයි කියනවා දැන් ඔයාව තමයි මට ඇක්සස් කරන්න. ඔයාගේ data එක මට එවන්න. රෙජිස්ට්‍රියට. නැත්නම් මම දැන් data එකක් එවනවා. ඒ data එක දාන්න ඕන ඔය කියන මෙමරි ලොකේෂන් එකට. ඕක යවන්නේ කොහොමද අපි? වයර් බිලියන ගණනක් දාන්නේ නැහැ මොකද කරන්නේ? ඩිකෝඩ් එකක් තියෙනවා මෙමරි එකේ processor එකේ ඉඳලා යවනවා address bus එකේ control signals. දෙකේ දිහා when you have 2 to the power 30 memory locations you just need 30 lines. 30 lines. ඔය 30 lines වල එක එක combination වලින් හරියට මොකක් හරි මේකක් අපි කියනවා. 30 line 30ක් කියන්නේ මහ කොටක් නෙමෙයි නේද? processor එකේ ඉඳලා memory එකට මේ තියෙන සෙන්ටිමීටර ගානක දුරන්නේ. ඒ කියන්නේ සිස්ටම් බස් එක ඇඩ්‍රස් ලයින් ඇඩ්‍රස් සබ් බස් එක ඇඩ්‍රස් සබ් බස් එකේ තියෙන කොයිද ලයින් 30යි if it is 1 GB. Okay, 1 GB and every location has 1 byte. ලයින් 30ක් කියන එක මැනේජබල් නේ. මේ ලයින් 30න් අපි සිග්නල් එක කන්ට්‍රෝල් සිග්නල් ලෙවල් කියනවා හරියටම මේ මිලියන ගාණක් බිලියන ගාණක් මෙමරි ලොකේෂන් වලින් කොයි මෙමරි ලොකේෂන් එකද දැන් අපි ඉන්ටරෙස්ටඩ් කියලා. And then when we read it, these are coming through a multiplexer because using control signals, we can say, okay, I need this particular data now, not the others. I need this particular data as the output, then I will send it to the processor. So you can see here we use decoders, here we use multiplexers. And inside the processor, this ALU unit, you have the adders. දැන් ඔය පොඩි sample දෙක තුනක් විතරයි කරේ යා. controls component දෙක තුනකුයි processing component දෙක තුනකුයි. Just to give you the feeling. But in reality, so how many transistors now? ඔයාලා අඩ එකකට logic gates කීයක් වුණා? Full adder 2 XOR gate නේද? දැන් full adder කරා. මම full adder එකට කීයක් වුණාද කියලා? 1 2 3 4 5 5. So using 5 logic gates, you can create a full adder. At 5 logic gates, 2 XOR, 2 AND 2 OR. Right? දැන් ගිහලා අහන්න බලන්න how many logic gates are in, right? How many logic gates are used in say i7 processor? Likely in the hundreds of millions. හරි මිලියන කියන්නේ බිලියන 1.4ක් තියෙනවා transistors. ඒ කියන්නේ මිලියන 450ක් තියෙනවා gates. එකකට ඕන 6ක් විතර. දැන් ඔයගොල්ලෝ දැන් මේ මිලියන 450 gates මොනවද කරලා තියෙන්නේ? V වපුරනවා වපුර යනවද? නැත්නම් මේ මිලියන 450 මොකක් හරි logic එකකට අනුව හදපු circuit. දැන් ඔයාලට හිතා ගන්න පුළුවන්ද? microprocessor එකක් හදනවා කියන්නේ කොච්චර ලේසි වැඩක්ද අමාරු වැඩක්ද කියලා. හරි මේ දැන් අපි තාම ඉගෙන ගත්තේ පොඩි encode එකක් decode එකක් multiplex එකක් full adder එකක් full adder එකට තෝරන gate 8ක් විතර. ඒත් දැන් මේ බිලියන 450ක් ඔයගොල්ලෝ මේ නිකන් දාලා බොරු ෂෝ එකකට පඩ ෂෝ එකට බිලියන 450 මිලියන 450 logic gate දානවා කියන්නේ නෑ. ඔය බිලියන 450 මොකක් හරි circuit එකේ කොටසක්. දැන් ඔයාලට දුන්නොත් එහෙම Intel එකේ ඉංජිනේර කෙනෙක් විදිහට ජොබ් එක කරන්න නම් ඔබ මෙච්චර සල්ලි දෙන්නම් කියලා යනවද? යනවද නැද්ද? මොකද මිලියන 450 ලොජික් ගේට් තියෙන process එක තමයි ඔයාලට තියෙන ඊළඟ i10 i11 i12 ඔයාලට තියෙන ඩිසයිනින් වලට සම්බන්ධ වෙන ඉංජිනේර කෙනෙක් විදිහට. ඉංජිනේර කෙනෙක් විදිහට කියලා තේ හදන්න බෑනේ Intel එකේ. Okay. So are you willing to do that? Are you ඔය අපිට ඉගෙනුවා නම් රස්සාදියව කිය කී ඉන්නේ උන් අල්ලලා දානවා ඔන්න ඔයගේ තැනකට. අනිවාර්යෙන්ම දිවි නසා ගන්න හවස වෙනකොට. එච්චර තැනකට දාන්න ඕන WSO2 එක වගේ එකට දැම්ම නම් බර්ඩ්ස් අය එක දැම්ම නම් ආයි එන්නේ නැහැ ලිප්ටන් වලට රවුමට. ආයි ලිප්ටන් වලට රවුමට එන්නේ නැහැ. හරි. එක්ක කොක්ක ගෙලිලා ඉඳි. එක්ක බිල්ලැජ්ජාවක් තියෙනවා නම් ආයි එන්නේ නැහැ. Okay. Right. ඔන්න ඔහම තමයි. ඔන්න ඔහම තමයි වැඩේ වෙන්නේ. හරි. Right. So we'll take a break. After the break, we'll move on to programming. Okay. අපි මේ නිකන් පොඩ්ඩක් සර්වර්ස් එක පොඩ්ඩක් අත ගන්න වැඩි විතරයි කරේ. Anyway, we are not going digital circuit anymore, right? Other than the sequential circuits. But if you are doing electronic all your 4 years, you learn these things. අවුරුදු 4ක් තිස්සේ ඉගෙන ගන්න මේවා තමයි. ඒතර හිතා ගන්න පුළුවන් නේද ෆයිනල් ඉයර් යනකොට මොනවද ඉගෙන ගන්න නැති කියලා. ඒතර ඔකට හිතනවා මේක අමාරුයි BIT ඩිග්‍රී එක පට්ට අමාරුයි කියලා. right? See. ඒගොල්ලෝ කොහොමද මේක කරන්නේ? මේක එච්චර අමාරු විදිහට හිතනවා නෙමෙයි. ඒගොල්ලන්ට කරන්නේවා තමයි මේ. Boolean algebra, capacitors, combinational logic, connectivity, counters. right? ඒක තව එහාට ගෙනියනවා. Logic gates, input output devices, oscillators, power electronics, mechatronics වගේ දේවල් වලට. මොකද ඒගොල්ලෝ මේවා ඉගෙන ගන්න තු ඒගොල්ලෝ ගිහිල්ලා ප්‍රෝග්‍රෑමින් ඉගෙන ගන්නනේ. පොල් ගන්න හැටි ඉගෙන ගන්නනේ. So let's take one topic like say combinational logic. The combinational logic circuit. Inputs, outputs. Output at any instance at time depends only on the combination of the inputs. දැන් අපි ඉගෙන ගත්ත එකම තමයි ඒගොල්ලෝ ඉගෙන ගන්නේ. මොකද ඒගොල්ලන්ට වෙනම ගන්නන්නේ නැහැ. මොකද ඕගොල්ලන්ට බොරු ඉගෙනනවා කියලා විතර. Combination logic circuits are memoryless. Memory එකක් නැහැ. ඒ කියන්නේ output depends on the input, not previous output. Only on the combination of its inputs. So the output depends only on the combination of inputs. Okay. Right. So these are the prerequisite to understand that Boolean algebra, truth table. හරිනේ අපි ඒක කරලානේ ආවේ. ඔන්න ඒවා දැනගෙන ඉන්න ඕනේ වැඩේට බහින්න. Right. You can use it for arithmetic and logic, data transmission, code conversion. හරිනේද? Arithmetic and logic වලට පාවිච්චි කරනවා 10 add එක. Data transmission, multiplexers, encoders, decoders, code converters, දැන් කරේ binary coded decimal, quaternary to binary. ඔයගොල්ලන්ට මේ ඒවත් තමයි කරන්නේ. ඒව කරලා චුට්ටක් කරලා නවත්තනවා හැබැයි. චුට්ටක් කරලා නවත්තනවා දෙලා නැත්නම් නේද? ඔව්නේ. ඒගොල්ලන්ට මේක නිකන් කටින් කියලා හරියන්නේ. ඒගොල්ලෝ මේක ඩිවෙලොප් හදන්න ඕනේ ඊට පස්සේ. ඒගොල්ලෝ ඊට පස්සේ මේක ට්‍රාන්සිස්ටර් එකට යනකම් තේරුම් ගන්නවා. ඕගොල්ලන්ට එච්චර යන්න ඕනේ. අවල් ලොජික් ගේට් එක ගාවේ නවත්තනවා. හරි. ඉතින් ඒගොල්ලන්ගේ ජීවිතය ඔක තමයි දැන්. මොකද හිතනවා මේ හරි අමාරුයි කියලා. ඉතින් මල්ටිප්ලෙක්සර්ස් ඉතින් අර මං කිව්වේ මේ වගේ අර එක ලයින් එකක් තමයි අවුට්පුට් එක. ඒක ඒගොල්ලන්ට දුගන්නන්නේ ඕක තමයි ඉතින්. ඉතින් සර්කිට් එක ඔක තමයි ඉගෙන ගන්න සර්කිට් එක. මේක NAND ගේට්ස් වලින් හදලා තියෙන්නේ. ඒක නිකන් ඇනලොග් ස්විච් එකක් වගේ කියලා මේ වෙන්නේ. ඒ වගේ කියලා. ඉතින් මේක එක විදිහට හදන්න පුළුවන් NAND ගේට්ස් වලින් හදන්න පුළුවන්. So one of the input is the output when you have different control signals. Right. හරිද? දැන් ආතල්නේ වැඩි. හරි. මොකද හිතනවා අනිත් ආතල් එකේ ඉන්න අපි අමාරුයි කියන්නේ අනිත් ඔයගොල්ලන්ට වැඩි මොලේ පාවිච්චි කරනවා හරි. Right. So after the break we'll move on to programming. Right. So let's continue. Now we are done with the combinational circuit, okay? Right. Combinational circuit. Now we need to do just the sequential circuit, then computer architecture. So we have just one tiny topic. It's a half an hour topic. Computer system subject is over then, okay? Computer system subject is over. For the batch, other batches, of course, information system is also pretty much over, right? Right. Right. So let's move on to arrays and finish arrays first. right? So then we want to finish methods also. Okay, so then we are into the object-oriented programming, right? So I will use in IntelliJ. So last time we discussed the one-dimensional arrays. We did not discuss the two-dimensional arrays, okay? We only discussed one-dimensional arrays. Right. So now you must have really good understanding about what is an array, right? So array is a data structure where one variable can keep multiple values. Individual elements are accessed using index. Index is zero base, like 0, 1, 2, 3. Array has a data type. When you create the array, you need to specify the data type and the size. You must only assign values of same type or compatible type, and you can't go beyond the size. If size is 3, only 0, 1, 2. Otherwise, you will get array index out of bound exception. Okay. And also, if you know the values upfront, you can create arrays in this approach as well. Or else, this is the normal approach. This way or this way. And then individually assign. Or you straight away create the array. Then you don't give the size because size is determined by number of elements. So then if you want to iterate, you can use normal loop, for loop, while loop, where the index is your control variable, or there's array friendly for loop. Array friendly for loop. So this is your array, and this is, if your array is float array, this must be a float variable. So then you don't need index because this will always iterate from 0th element to length minus 1 or the last element. Okay. Right. So that is 1D array. So then we can extend this into 2D arrays or 3D arrays or any number. Okay. Let's create another Java class. 2D array. Say demo. So two-dimensional array is something like this. You have two dimensions. So this is the row and this is your column. So first we refer to the row, then we refer to the column. So therefore this element is 1, 2. Say this my array is X. So this element is X1, 2. This element is X2, 0. Okay. So when you create an array also, you need to specify what are your number of rows and columns. And again, you need to give the data type. You can only assign values of same data type or compatible types. You can't assign values outside the range. You get array index out of bound exception. So array scan. So let's have main method. Again, we have two ways to create the array. If you don't have the data, first approach. If you have the data, the second approach. Right. Say, let's create a two-dimensional array. Say A equal new int. So let's say this is number of rows. Say number of rows is 2 and number of columns, let's say 3. So this is 2 by 3 array. 2 rows, 3 columns. 0, 1, 0, 1, 2. Now you can have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. First the row. Okay. So let's assign some values. say A 0 0, say 10. So likewise, you can assign values. Say 0 0 0 1 0 2 1 0 1 1 1 2 and so on. Say this is 20, 30, 40, 50, 60. Now you can just print or whatever I S out. Say A 0 0. So this will be 10. It's two-dimensional array. Zero zero element is 10. Yes. And if you try to refer to something outside the range, you will get array index out of bound runtime exception. Say there's nothing called 1. Say there's nothing called 0 3. If you try to access 0 3, you will get an error. Error. You must know the error name was array index out of bound exception, runtime exception. Sorry, this must be square bracket. Right, no compile errors. No compile errors, but runtime error because there's no 0 3 element. You can see array index out of bound exception. Okay. So that is the first approach. So second approach is if you know the data. Say B. So you can have the two curly brackets. So then each row. So this is my zeroth row. Say first row. Say second row and so on. Say first row. So let's have only two rows to make it simple. So these are my data. I'm just creating the same array now. 10, 20, 30. And first row, that is zeroth row. First row, 40, 50, 60. So I create exactly same type of array. 0 0 is 10, 0 1 is 20, and so on. So 0 0 is 10. Okay. So I'll comment this, otherwise it won't execute beyond this. And again 10. But if this is 0 1, it will be 20. Right? 20. Is it clear? So this is called 2D array. Okay. So how do you iterate? Iterate. So again, you can use for loops like this, or there's easier way, array-friendly for loop. So I'll first show you the harder way, a normal for loop. So now you need nested for loop. First loop going this way, for each row, other loop going this way, other loop going this way. Okay. Right. So therefore it's a nested for loop. Then what ටික data process කරන විදිහත් පුරුදු වෙනවා. බය නැති වෙන්න. Programming කරන්න. semester 3 වලට ගියාම data structures and algorithm කියලා subject එකක් තියෙනවා. ඒකේ මේව නෙමෙයි. මේව trees එහෙම දිගේ search process කරන් යන්න ඕන. හරි. මොකද binary trees එහෙම දුන්නම code ලියන්න පුළුවන් වෙනවා. හරි. ඔයාලට මේ මුළු binary tree එකම traverse කරන එක්තරා logic එකකට. මෙහෙම ගිහිල්ලා ඔහොම ගිහිල්ලා. හරි. මේ binary trees rotate කරනවා. අන්න coding මේව මොනවාද? තාම මේ නිකන් පටන් ගන්නවා විතරයි හොඳේ. තාම පටන් ගන්නවා. හරි. Right. So let's iterate. ලස්සනට iterate කරමු. 0 row එක first row එක approach 1. So අපි for loop එක use කරමු. මොකද while loop එකට වඩා for loop එක ලේසි. ඔන්න rows යන for loop එක. ඔන්න each sorry ඒ තමයි row by row යන එක. මෙන්න එක row එකක තියෙන columns ටික යන එක. හිත code එක ලියන්න ඕන. නිකන් ඔහෙ ලියන්න බෑ. So therefore this goes from මට එකක් කියන්න අමතකුණා. මට rows ගන්න ඕනේ නම්. So if you want the number of rows in your 2D dimension මෙතන length කියන පාවිච්චි කරන්නේ නේද අපි? length පාවිච්චි කරන්නේ. In 2 dimension array. So let me print it. If I SOUT. So if I print b dot length, what is the value? So now this is a 2-dimensional array. For 2-dimensional array, the length is number of rows. Number of rows. So that is 2. That is 2. අපි එකක් බලමු. Length කියලා එන්නේ number of rows ගන්න. හොඳේ? Yes. Now if you want to know the number of elements in a row, ඒක වෙන වෙනම row එකෙන් row එකට වෙනම අහන්න ඕන. For example, you can say what is the length of B0, that is 0th row's length. 0th row length. 0th row එකේ length එක කීයද? 3යි. 1 2 3. 0th row එකේ නෙමෙයි first row එකේ length එක 3යි මෙයාගේ. But this is 3. So this gives you number of rows. So this is how you ask length of a row. First you need to say which row and then length property again. Okay. In this case it is 3. Okay. අපිට මොකෝඩ් නැත්නම් for loop එකේදී. ඔයාලට එකපාරට කමෙන්ට් එකක් බ්ලොක් එකක් කමෙන්ට් කරන්න ඕනේ. ඒ සිලෙක්ට් කරලා control/. It's a block. It's a toggle. සමහරවිට මුළු බ්ලොක් එකම කමෙන්ට් කරන්න වෙනවා. Now this goes from 0 to I equals 0 because first one is the 0th row. As long as I is less than or equal to I less than මොකද? rows ගානට වඩා අඩු වෙන්න ඕන. rows ගාන 2යි නම් 0 1 කියලා නවත්තන්න ඕනේ. right? නැත්නම් hard code කරනවා 2 1 2 කියලා. I plus plus. So that is you are going row wise. Now for each row, now you need to go column wise, cell wise. Let's use a different variable. J equals 0 because that is also first one is 0. The J is less than B-ith length. කල්පනා කරලා බලන්න මම ලියන විදිය හරියද කියලා. B කියන array එකේ ith row එකේ length එක. Then of course J plus plus. Now I can print B arrays ith rows jth column. I will use print rather than println because I want to print horizontally. Maybe a space. And after you complete full iteration of the row, I want to take the next row into the second line. Next line, I will have printed. One hardika logic. So output must be 10, 20, 30. In next row 40, 50, 60. If this is correct. Correct, right? 10, 20, 30, 40, 50, 60. I just iterated this B array. Okay, so that is how you iterate 2D array. Row from 0th row to the last row, each row 0th column to the last length minus 1 column. So that is using normal for loop. But if you use this array friendly for loop, things are easier. Things are easier. So let's use second approach. ඔයගොල්ලෝ මේක කරලා ඔයගොල්ලෝ තනියෙන් කෝඩ් කරන්න ඕන හරි ක්ලාස් එක වුණාම හරියට. Iterate approach to. So again, we need nested for loops. Nested for loops. First outer loop row wise. Okay. So remember now each row is one-dimensional array. Each row is 1D array, 1D int array. So therefore the result is int array. Int array. Let's call it P in my B array. B is my 2D array. B is my 2D array. හැබැයි ඒක පළවෙනි row එක තමයි මේ තියෙන්නේ. It's a 1D array. Now I need to iterate the 1D array. And each element is a int. In Q in my P array. ඔබ පුරුදු වෙලා ඔළුවේ කල්පනා කරලා මේ කෝඩ් එක ලියන්නේ කටපාඩම් කරලා නෑ. Now I can print my Q. And also I will have a space because it's going to go through each and every element in the row. After the row is iterated, I will pause it to go to the next line. Blank println. මේ දෙක අතර පොඩි gap එකක් දාමු අපි නැත්තම් හොයාගන්න බෑනේ. Something like this. Okay. So that means we are going to get the same output again, but using the other loop now. Array friendly for loop. You can see this is more compact. But here you have int array because each row is a 1D array. And then we iterate that 1D array one by one. Print ln තියෙන්නේ. So this must be print. Right. So this is using the normal for loop. This is using the array friendly for loop. Right. Then මේක නිකන් එහෙම අමාරුයි වගේ තේරෙනවද? එහෙම අමාරුයි වගේ තේරෙනවද? මේ තියෙන්නේ semester 3 වල තියෙන code. while එක ඇතුළේ if දාලා ඒක කොහොම ලියන්න ඕනේ මේ problem solve කරන්න දැන් හරි problem solve කරන්න. Let me give a data structure code also. Right. So this is a quick sort. Quickly sort කරගන්න algorithm එක. Right. දැන් code දාන්න exam එකේ කෙලිම code එක ගන්න නැහැ හොඳේ බය මේ code ලියන්න ඕනද කියලා. දැන් මේ code එකේ තියෙන logic එක ආගේ ඔළුවේ තියෙනවද කියලා ඒගොල්ලොන්ට check කරන්න පුළුවන් question වලින්. Okay. Right. So this is a tree. මම කිව්වා tree එකක් දිගේ යන්න පුළුවන් කියලා අපිට. ඔන්න තියෙනවා code. The break, while loop. So it doesn't mean that in the exam they ask you to write this kind of a code. But they check whether you can understand this kind of code. ඔයාලට සමහර පැයක් විතර දුන්නොත් ඔයාලට කෝඩ් එක ලියන්න පුළුවන් ඇතර. කල්පනා කරලා. හරි. ලොජික් එක කල්පනා කරලා වරද්ද මේ කෝඩ් එක ලියන්න පුළුවන්. මේවා අපි ලියන්න ඕනේ නැහැ. මේවා ඉන්ටර්නෙට් එකේ සර්ච් කරාම අහුවෙනවා. හරි. හැබැයි සර්ච් කළා වුණාට නැහැ නේ මේක තේරෙන්නේ නැත්නම් අපිට මේක වෙනස් කරන්න මේ වගේ වෙන වැඩක් කරන්න බෑනේ. ඒකට මේ බය නැති කරන්න තමයි මේ ටික ටික කරන්නේ හොඳේ. සහ මේ arrays වලින් තමයි ඊට පස්සේ අපි data structures ඉස්සරහට කොට හදාගෙන යන්නේ. ඉස්සරහ. Trees, graphs. Okay. Right. So that is how you iterate two-dimensional array. Either using for loops, normal for loops, or even easily use array-friendly for loop. But this for loop has lot of flexibility because we can iterate from bottom to top, right to left, ඕන විදිහට iterate කරන්න. මේක හැමතිස්සෙම යන්නේ top to bottom, left to right. But most of the time this is good enough. Okay. දැන් මේ වගේ for loop හැම language එකෙම තියෙනවා හරිය. Java විතරක් නෙමෙයි C# වලත් තියෙනවා, PHP වලත් තියෙනවා. Right. So any question? So if you want, you can create odd shape arrays also. Very rarely we do that, but yes, possible. දැන් අපි මෙච්චර හැදුවේ ඍජු කෝණාශ්‍ර සමචතුරස්‍රය නේද? මෙහෙමනේ arrays හැදුවේ. Right. For example, if there's a requirement, you can create an array like this. This one has only 2, this one has 3. Right. Maybe this one again has 2, or maybe this one has 4. ඔන්නෝම arrays හදන්න පුළුවන්. Maybe this one has only 2 again. So this number of elements in a row can be varied. Okay, can be varied. So that is called array of arrays. Array of arrays. Each row is another array. So how to create that kind of array? Of course, if you have data like this, it's the same. මේ වගේ data දාද්දි එහෙම දාන්න. For example, say එහෙම නැත්නම් කෙලින් මේව හදමු. මේව හදමු. Right, let's create say int. මම int පාවිච්චි කරන lazy අංග. C equal new int. Remember last time we give both number of rows and columns, but this time we are not going to give, right? So last time we give both number of rows and columns, then it's a rectangular square array. But this time I'm going to give only number of rows. I'm not going to give the columns, which I keep open. Okay, so then you need to create each row one by one. Say C row equal new int. Let's say first row has 2. Okay, 0th row. Say first row has first row has 3. Let's say the next row has අපිට rows තුනක් තියෙනවා 0 1 2. අපි හිතමු එයාගේ තියෙන i 2යි. 0 1 2. දැන් හැදි මොන වගේ array එකක්ද? මෙන්න මේ array. First one has 2 element, next one has 3 element, and again you have 2 elements. ඔන්න ඔහම array එකක් දැන් හැදුවේ. Okay, so now you can assign values like C so මෙතන 2යි, මෙතන 3යි, මෙතන 2යි. 0 0 0 1 2 0 sorry 1 0 1 1 1 2 3 0 and 3 1. මම හදපු විදිහට තමයි data දාන්නේ යා. ඔය දෙකෙන් දාමු 10 20 කියලා ඒ විදිහට දාමු 10 20 30 40 50 60 70. Okay, so this must be 2, right? So this is now 10 20 30 40 50 60 70. Okay, 70. ඔන්නෝම array එකක් තමයි හැදෙන්නේ. memory waste කරන්නේ නැතුව. මොකද මෙතනට memory දාන්න allocate කරන්නේ නැහැ දැන්. 10 20 30 40 50 60 70. Now if you want, you can iterate. You can iterate either this way or this way. මේවා කෙලින්ම දැන් වැඩ. මේ general විදිහට ලියන්නේ ඒකයි. එකම දැන් මේක මොකක්ද? C. This is C. Okay. මේ ඊට ටිකක් දාමු. බලන්න 10 20 30 40 50 60 70 කියලා නේද? අන්න එක්සෙප්ෂන් එකක් පැන්න. BIJ. මෙයා B නෙමෙයිනේ දැන්. C නේ. C right. අපි අලුත් ඇරේගෙනම C නේ. තවකන් තියන හරි. Now it should be okay. C length, CI length, correct. Right. 10, 20, 30, 40, 50, 60, 70, 20. Or you can use our array friendly for මම මේ loop එක අකුරක්වත් වෙනස් කරන්නේ නැහැ. මොකද මේ loop ලියලා තියෙන general විදියට. General solutions ලියලා තියෙන. So now it is C. And C කරන්න විතරයි. So you will get the same output again now, second time. Can see? This is normal for loop. This is array friendly for loop. So අනිත් විදිහට හදන්න පුළුවන් අපිට මේ curly bracket approach එකෙන් හරි. මෙන්න මෙහෙමත් අපිට ඔය odd shape array හදන්න පුළුවන්. Say 10, say this is now D. Say this is 10 and 20 only. Make it a lazy with it. Then we have the 30, 40, 50. So then you need the third or the second row, 60, 70. I think. දැන් ඔකත් අර වගේම iterate කරන අර උත්තරේ වෙනවා. උත්තර තියෙන මේකම තමයි මේ හැදුවා. So same content we built using this approach. So this one also now you can iterate, you will get the identical output. Right, any questions? Any questions about arrays in Java? Java වල arrays ගැන වෙන ඉගෙන ගන්න දෙයක් නැහැ. ඒකත් මතක තියාගන්න. ඔයාලට උගන්නලා ඉවර කරන එක මේ හිමින් කරන්නේ. හරි. අපිට ඉගෙන ගන්නකොට ඉගෙන ගන්න පුළුවන් විදි දෙකක් තියෙනවා. ඉගෙනගෙන ඉවර කරනවා, චුට්ටක් ඉගෙන ගන්නවා, භාගෙට ඉගෙන ගන්නවා. හරි. චුට්ටක් ඉගෙන ගන්නවා, භාගෙට ඉගෙන ගන්නවා, ඉගෙනගෙන ඉවර කරනවා. මේ කරන්නේ approach එක මොකද? ඉගෙනගෙන ඉවර කරනවා. ඒකට කවුරු හරි කිව්වොත් එimhe අපි Java arrays ඉගෙන ගමුද කියලා කියනවද මොකද්ද? එපා. බෑ. එච්චරයි. එච්චර කතන්දරේ. ඇයි කියලා හුවොත් මම ඔක්කොම Java arrays දන්නවා. අන්න ඒකට තමයි confidence එක කියන්නේ. එතකොට එයා කියනවා ආයෙනම ප්‍රශ්නයක් අහන්නද? අහන්න. arrays වලින් පොඩි කෝඩ් එකක් ලියලා දෙන්න පුළුවන් මම ලියලා දෙන්න. අන්න ඒකට තමයි confidence එක කියන්නේ. දැන් සමහරව අවුරුදු 10ක් ඉංග්‍රීසි ඉගෙනගෙන මොකද කරන්නේ? ඉංග්‍රීසි ඉගෙන බෑ. මොන කාලකන්නිකමද? ඔයා කියනවා ඉංග්‍රීසි ඉගෙන ගමුද? බෑ. ඇයි ඒ? මට පුළුවන්. අවශ්‍යකම මට පුළුවන්. මොකද ඉංග්‍රීසි වගේ සබ්ජෙක්ට් එකක් ඉගෙන ගන්න බෑ මේ. Java ඉගෙන ගන්නවා නේද? ඔයා ගිහිල්ලා මේ ෂේක්ස්පියර් එක කතා කරන්න නෙමෙයි මම කියන්නේ. මට මගේ සාමාන්‍ය වැඩ ටික කරගන්න ඇති. හරි. ඒතර දැන් ඔය ඔහොම කියනවට සමහරව කැමති නැහැ. හරි. දැන් අපි කියන්නේ කොහොමද ආට? ඔයාට කියනවා මට ඉංග්‍රීසි පුළුවන්. දැන් මට පුළුවන් ගිහලා මගේ වැඩ ටික කරගන්න, මගේ ස්ටඩීස් කරගන්න, එක්සෑම් එකේ උත්තරයක් ලියන්න, ඉන්ටර්විව් එක ෆේස් කරන්න. දැන් ඒතකොට ඉන්න ඉංග්‍රීසි විතරක් පුළුවන් ගේ උන් සෙට් එකකුත් තියෙනවා. වෙන මෙලෝ මගුලක් බෑ උන්ට. හරි. උන්ට මැනේජ්මන්ට් උත් බෑ, බිස්නස් උත් බෑ, IT බෑ, කුඹුරක් කරගන්නත් බෑ. උන් දන්නේ ඉංග්‍රීසි විතරයි. එතකොට උන් ඇවිල්ලා කියනවා ආට නෑ නෑ වාට ඉංග්‍රීසි බෑ. හොඳයි ඔයා කියන්නේ නම් කිරියගුණ කොළ වලට ඉංග්‍රීසියෙන් කියන්නේ මොනවද? ඒකට අල්ලලා කිරියගුණ කොළ බාල්දිය උගේ ඔළුවේ නාලේ වටනවා. ඒ ඇවිල්ලා බොරු සීන් හරි. ඒව අපිට ඕනේ නෑ නේද? ලොවෙත් නැති ඉංග්‍රීසි. හරි. ඒව අපිට ඕනේ අපේ වැඩ ටික කරගන්න ඉංග්‍රීසි. කොස්සෙන් අතු ගන්නවා මිසක් කොස්ස වනවන යන්නේ නෑ අපි. කොස්ස ඔලුවට තියාගෙන යන්නේ නෑ. කොස්සෙන් අතු ගෑව කොස්ස තිබ්බා අපි වැඩේ කරා. ඊට පස්සේ ඉදලෙන් වැඩේ ගත්තා. අපිට ගණිතයත් එහෙමයි. ප්‍රෝග්‍රෑමින් උත් එහෙමයි හැම එකම එහෙමයි. මේවා මේ කැටයන් නෙමෙයි. අපිට අවශ්‍ය වුණාට අපි ඉගෙන ගත්තාම වැඩේ ඉවරයි. ඕක හැමදාම ඉගෙන ගන්න බෑ. දැන් වැඩ කරන්න පටන් ගන්නවා. right වැඩක් කරන්න. සමාජයට වැඩක් වෙන විදිහට ජීවත් වෙන්න. ගෙදරින් ගෙදර අම්මලා තාත්තලා නිදහස දෙන්න ඕන දැන්. Right, so that's it about arrays. Okay, that's it about arrays. Right, our next topic is methods. Right, next topic is methods. So then structured programming is over. So that means 1/3 of the syllabus is over. 1/3 of the programming is over. Okay, 1/3. But last topic we can do faster. මොකද ඉස්සෙල්ලා පටන් ගන්නකොට හිමින්නේ පටන් ගන්න නේද? ඊට පස්සේ වැඩේ confidence එනකොට හයියෙන් යන්න ඕන. Right, methods. So far, what are the topics we have discussed under structured programming? We have discussed variables and data types, including casting and so on, literals. So then operators. Then we discuss about control structures, including break and control. And today we finish arrays. Arrays are also related to variables and data types because we are either working on data or process. So now our final topic is methods. Methods are again related to processing. මේ processing topics, මේ data topics. තව data topic එකක් අපට පස්සේ එනවා collection framework කියලා. ඒක collection framework, enumerations. හරි තව data topics දෙක තුනක් තියෙනවා. මම ඒවා කරන්නේ හිමීට. So you can see here there's something called collections, another data topic. Wrapper classes, data related topic. Enumeration, data related topic. String handling, data related topic. ඔය තියෙන තව data topic පස්සේ. ඒවා කරන්නේ object oriented කරලා. Right, object oriented කරලා. Right, methods. So let me copy this code. Six methods. Right. Methods are reusable code chunks. Right. So when you write code, you can keep write code, right? So far we have been writing coding in main. මේ ඔය ලියන මාදලක් වගේ. Right? But that is not going to work, right? When you are developing a complex software with thousands of lines. So in your software, there will be some functionalities which we use over and over. So then what is the point of writing the same code over and over? So what you can do is you take it to a method. So then you just call it. Right? Maybe again you need to call that method. So you just write it only once. So whenever you need that function, you just call the method. So likewise, these reusable things, if the same code repeats, we can take it into a methods and then call that methods. So then your effort is less, easy to maintain, easy to manage, lesser code, and so on. Okay. And we can write our own methods. And not only that, even Java has its own methods, built-in methods like println method. So rather than we write the println method, they have written it and we use it. So then we can write our own methods and we can reuse it. Or someone else can reuse it. That is called reusability. of code. Some validation logic, say how to validate a credit card number. If someone has written that method, you just copy paste and call it. Why do you want to write same thing? Okay. මිනිස්සු කරපු අපි ආයි කරන්න ඕනේ නෑනේ. Okay. So it promotes reusability, divide and conquer, maintainability, and so on. So this is the structure of a method. For the time being, all our method will be static. But after you learn object-oriented programming, you will learn how to write non-static methods. Okay? But for the time being, assume all our methods are static methods. So your method must have a name. Optionally, you can have parameters so that you can send some data to the method. Optionally, you can have return. If you don't have return type, you must say void. And if you have return data type, you must return. If your return is void, you don't write return. So the only compulsory thing is method name. And return type void though parameters are optional. Return type is optional, but if you don't have return type, you must say void. If you have a non-void return type, you must have a return statement. Otherwise, you can't have return statement. Okay. Right. So let's do a bit of coding. This is a very small topic. Okay. Right. Say method demo. Right. So remember our main method is also method, right? PSVM, that is also method. So that is by default the starting point of your execution. And you can see your main method is also static method. Okay, right. So let's write a method. Say add, or let's say hello, void, no return. Say hello. This is sort of a simplest method, but make sure your methods are static. දැනට ඔය public ඒවා ගැන හිතන්න එපා. ඒවා පස්සේ කරනවා. Access modifiers. Right. So let's say sound hello. දැන් මේකට method එකක් ඕනේ නැහැ. හරි මම මේ. So now you can call this. Say hello. So this is you call your own method. So when you call say hello method, it comes here and print hello and then come back here and you are done. End of the method. Main method. Okay. So the output is hello. Now, if you want to see how it happens, you create a breakpoint. Breakpoint at done. Right click debug. Now control has come to this point and stopped. So now remember last time we used step over. If you want to go into the methods, just use step in. يعني method එක ඇතුළට යන්න. ඔන්න නම් step in කරනවා. Now we are in say hello method. Then step in කරන්න එපා. Then step in කරොත් then print ln method එක ඇතුළට යනවා. Then step over. You are back. You are at the end of the say hello. Then you will be at the end of the main. Because say hello has returned. Now we are done. That's it. Okay. So this method doesn't return anything. Void. This method doesn't have parameters. It doesn't take any input. So let's write a method which take inputs. So let's call it int add. And let's have two parameters, data type, variable, parameter name. Okay. I will add the two numbers. If you have variable inside the method, that is called local variable. Right? Local variable. Let's say total. In total. That is a local variable. Okay. ඕන්න මෙතනම අපිට x y y එකතු කරන්න නම් වෙනම එකතු කරමු. Total equal. Say you can use your parameters just like your inside variables. Now you will print. Say total is, say total. So we have two parameters and we calculate the summation of these and print. Now when you call that method, you must send arguments because it expects two integers. Now you must provide two integers, say 10 and 20. So we don't return anything. So then 10 plus 20 is 30. 30 will be print after say hello. Total is 30. Now if you want, you can do a debug point, add a debug point here. Debug. මේක debug කරලා බලන්න ඕනේ. එතකොට ඇඟට තේරෙයි. මෙතන නැවතුණා. Now step in. Step in. දැන් ඔයාලට පේනවා x is right, x is 10, y is 20. Yes, x is 10, y is 20 by position. Now you are going to add 20 and 30. Now still total is no value, but now total is 30. Now when you print total, 30 will be print. Right, 30 is print and we are done. Right, so that is how you have parameters. You can have different type of parameters, different number of parameters. Then make sure you send compatible arguments. Like for example, I can't send this as 10.5 because 10.5 is not a integer. So you can see compile error. So then you can return something also. Right? So let's have another method. But this method is going to have two parameters. Let's say sub. But rather than you print it, you are going to return it. So then you must say what is your return type. Let's say int. Then if you have return, you must return. Say sub diff or something. Say x minus 5. Now I can return it rather than printing. Now this method has two parameters and return type. Now when you call, you can't just call like this because it's return something. Okay. I'll make 100. Right? Sorry, sub. This work, but your return value is lost because you are returning a value. So therefore, if you want to no compiler, but it's useless. So then assign it to a variable. If you are returning int, assign it to variables. Yeah. Now you have the return value. That is 80. Now you need to, if you want, you can print it. Say difference is so it will be 80, right? Right, 80. Total is 30. Why do we get two times? May total total. Total is දෙපාරක් කරන්නේ. ඇයි? දෙපාරක් කෝල් කරා. ඕනේ මේ වැරද්ද දෙපාරක් type කරා. Right. Now it's මම ලිව කෝඩ් එක මම දන්නවා. මම එහෙම බලාපොරොත්තු වෙන්නේ නැහැ. Right. Now it's correct. Okay. Right. So any questions? Okay. And you can have different data type for different parameters. So make sure you send the compatible values, arguments. Otherwise, you will get errors. So this is your local variable, right? ඔක්කොම note එකේ තියෙනවා හරි. And the other thing is, just like you have multiple methods, one method can call other method as well. For example, let's say I have a method called foo. Say void foo. Say sub foo. Now how do you call, sorry, make it static. So how do you call foo method? You just call the foo method. That is not magic, right? So there will be output called foo. Now, if you want, your foo method can call another method and so on. Method chaining. එහෙම කරන්න පුළුවන්. Say foo method call bar method. So then you need to call that. See, දැන් ඔය අරයා call කරන foo method එක method එක එයාගේ වැඩේ කරලා bar method එක call. මෙයා return වුණාම තව මොන හරි වැඩක් තියෙනවනේ edit කරලා තමයි මෙයා return වෙන්න ඕන. And let's say foo start. Say this is my foo end. Foo end වෙලා තමයි අරහෙට යන්නේ ආයා. කරලා බලන්න කියන්නේ ඒකයි. Now what will be the output? So you call foo method. So therefore control come here. Then the output will be foo start. Then you call bar method. So then there will be bar. So then you are coming back here because bar is done. Then you say foo end. Then you are going back to the main method and you are done. And name control again. Debug කරලා ඕන නම් බලන්න. Foo start bar foo end. එහෙම නැත්නම් මෙතනට කියලා debug point එකක් දාන්න. Debug step in. දැන් ඉතින් ගෙදර වගේ තමයි යා. ඔන්න foo එකට ආවා step over කියන්නේ ඊළඟ line එකට යනවා. දැන් මම කියන step in right I'm in bar. Now I'll be coming back to my foo. Now foo එකට දැන් මේක output එක යනවා. ඊට පස්සේ ආයි main method එකට යනවා. And now back in the main method. Done. Okay. So then these are called local variables. Method variables declared inside a method is called local variables. If you want, you can declare variables outside methods. So then we call it global variable. Global variable. Say, again, I will make it static because for the time being, you can use only static variable, static method, okay? But local variables, you don't need to make it static, but global variables, for the time being, let's make it static. But when you learn object-oriented, you will learn how to use non-static global variables, okay? How to use non-static global variable, how to use non-static methods. That is when we do the next topic, object-oriented programming. Say static, say int, let's call G, say 12. This is a global variable. So global variables can be accessed from any method. Any method. Okay. For example, in your main method, you can access global variable. Say G is G. So global variables are accessible from any methods. That is why global. Local variables, for example, this variable is visible only here. This variable only in this sub method. But this variable, any method can access, including your main method. That is what is meant by global variable. Right? G is 12. And also if you change it, that difference, that change is visible to other methods from that point onwards. Okay, from that point onward. අපි හිතමු මේ bar method එකේදී G වෙනස් කරලා තියෙනවා කියලා G++. right. දැන් මෙතන output එක එනකොට දැන් අපි bar method එක පාරක් call කරලා එන්නේ. bar method එක call කරන foo එක හරහා මෙතෙන්දි 10යි. foo එකට කලින් 10යි. foo එකේදී bar එක call වෙනාද දැන් ඔන්න increment වෙලාදී. දෙවෙනි පාර එනකොට 11. ඒ වෙනස ආට පේනවා because it's a global variable. Sorry, 12 කියලා කොහොමද? G මම 12 ගන්න පටන් ගත්තේ. Yes, first it is 12, then it is 30. Then it is 30. Why? Because foo call bar has incremented it by 1. So therefore, then when we print, it is 30. Global variables, changes are visible to any other method because it's a global variable. ලෝකල් වේරියබල් කියන්නේ ඔයාගේ පොත වගේ. ඔයාගේ පොතේ ලියන්නේ ඔයාට විතරයි අදාළ. ග්ලෝබල් වේරියබල් කියන්නේ පන්තියේ තියෙන බ්ලැක් බෝඩ් එක වගේ. ඒතර බ්ලැක් බෝඩ් එකේ මොන හරි වෙනසක් කරාම මුළු පන්තියම බව කියනවා. මුළු පන්තියේම තියෙන එක බ්ලැක් බෝඩ් එකයි. Global variables are like that. Okay. Any questions? And final concept is related to methods, recursive method calling. So this is normal method calling, right? Main method called the foo method, the foo method called bar method. That is not recursive, right? Nimal called Amal and Amal called Kapila. So what about Nimal calling himself? නිමල් කියලා කතා කරන නිමල් මෙන්න මේ වැඩේ කරලා දීපන්. ඒක දැන් කවුද කරන්න ඕන වැඩේ? නිමල්ම තමයි කරන්න ඕන. මොකද නිමල් කියන්නේ යානේ. So that is called recursion. Method calling itself. Okay. For example, let's say recursion demo. Say main method PSVM. Sorry. Public static void main. Say I have method. තාම අපි ලියන්නේ static method විතරයි. Static void say foo. Say s out foo. Say we call foo. This is nothing fancy, right? So the output will be foo. Output is foo. This is not recursion, right? Because main call foo. But what happens if foo call itself? Then foo bar call කරාට කමන්නේ නැහැ හරි. එහෙම අපි කඩන කරා. So what about foo call foo? So that is called recursion, recursive call. දැන් මොකද output එක? කොල්ලකට තියෙන B if you have two plane mirrors, what happens when there's object? So there's an image, there's another image, then that image become object to this, another image, another image. So infinite number of mirror images. එහෙම කරලා තියෙනවා මම නම් මොන දාලා බලලා තියෙනවා මොකද වෙන්නේ කියලා. මොකද අපිට කුතුහලයක් තියෙනවනේ කවුරුත් කියන විශ්වාස කරන්නේ නැහැ. So this is also same, right? So you call foo, then output is foo, then you call yourself, again output is foo, again you call yourself. So this is a useless code, never ending recursion. ටිකක් වෙලා ගිහලා ඔයාගේ OS එක මෙයා JVM එක මේක ස්ටොප් කරනවා. මොකද එයා දන්නවා මේක ඉවරයක් වෙන්න මගුලක් කියලා. හරි තියෙන ස්ටොප් උනේ. හරි. එයාම ස්ටොප් කරලා දාන්න නැත්නම් මේක මෙමරි ඕවර්ෆ්ලෝ වෙනවා. ටිකක් රන් කරලා ඊට පස්සේ නවත්තලා දාන්න. But this is not useful, right? But there are problems we can use recursion to solve those in a smart manner. That means there are some problems which are recursive in nature. So that means you can't use recursion to solve all the problems, but there are some problems which are recursive in nature. So those problems we can solve programmatically using the concept of recursion. If you use recursion in a smart manner, right? So you have a subject topic called recursion in semester 3 data structures and algorithms. But here because recursion is heavily used in problem solving. Search algorithms, sort algorithms, traverse in binary trees. ඔය යන හැම තැනම recursion use කරනවා. Recursion දාව ගමන් solve කරන්න lazy. හරි. solve කරන්න lazy. ඔය තමයි දැන් ඉස්සර recursion පෙන්වන්නේ. Now if you take these sorting algorithms like quick sort, selection sort, මේ ඇතුලේ තනිකර recursion වලින් ගේම ගන්නවා. වෙනවද මේක quick sort කියන method එක මායි call කරලා තියෙනවා. That means you call yourself. can see recursively sort elements. Recursively sort. So you call yourself, but conditionally. Otherwise, it's a never-ending loop. එහෙම recursive කරන්න යනකොට problem එක solve වෙනවා. හරි? ඒක පට්ට concept එකක්. Right? So therefore, this is just a starting point. Okay. So you just need to first familiar with what is recursion, method calling itself. But this kind of method calling itself is crazy, right? And so this is crazy recursion demo, right? Never-ending recursion demo. But there are practical usages. Because there are some problems which are recursive in nature. So one famous problem is factorial, calculating factorial. Right? For example, so in mathematics, there's a concept called factorial. I don't know whether you have learned this in your O level. So by definition, factorial 0 is 1 by definition. Factorial 1, this is the symbol we use, exclamation, is 1. Factorial 2 is 2 into 1, which is 2. Factorial 3 is 3 into 2 into 1, which is 6. Factorial 4 is, by definition, this is a definition, 2 into 1, which is 24, and so on. So therefore, you can see there's a pattern. Factorial 4 is 4 into factorial 3. Factorial 3 is 3 into factorial 2. It's recursive. So therefore, I can say that factorial 5 is 5 into factorial 4. In other words, factorial n is n into factorial n minus 1. Factorial 100 is 100 into factorial 99. Factorial 99 is 99 into factorial 98. So that is a recursive solution, recursive concept. If you want to calculate factorial 100, you can use recursion to solve that problem. Of course, you can solve that problem using loops also. But at the same time, you can solve it using recursion. Right, I'll give this as a exercise because I don't want to do this. See whether you can, so you must write a function, right? Int, static int, say factorial or something. You send a parameter x. You are supposed to return, if you send parameter as 2, you return 2 because factorial 2 is 2. If you send 3, you return 6. If you get 4, you return 24. You need to write the logic. You can write it in two ways. With recursion, you can write it. Without recursion, using a loop, you can write it. For loop, for while loop. Try to solve this either using at least one approach or both approach. And then Google search දාන්න බෑ, ChatGPT දාන්න බෑ. තනියෙන් කරන්න ඕන. තනියෙන් කරලා ඉවරලා ඩබල් කරන්න බැන්න ChatGPT එකෙන් එවට කමක් නැහැ. හරි? Right. I will do that in the next class. Okay. So then we will move on to object-oriented programming. Again, object-oriented programming we will do very slowly, but that is a critical subject, the most critical topic in your programming. Object-oriented දන්නේ නැහැ කියන්නේ මෙලෝ මගුලක් එතනින් එහාට තේරෙන්නේ නැහැ. Semester 1 තේරෙන්නේ නැහැ, 2 තේරෙන්නේ නැහැ, මුකුත් තේරෙන්නේ නැති වෙනවා. Okay. So therefore, we'll do it very slowly, object-oriented, because we don't target your exams. We target your career, your profession. Right. We stop at this point. Right. Thank you.